Hi everyone, welcome here in Budapest. My name is Zoltán Gombár. I'm head of Competence House Open Telecom Cloud and Hyperscalers in DTITS. And I'm very much honored to be your host today because this is the first ever OpenInfra Day in Hungary, in Budapest. And without any further ado, I would hand over to our first speaker, László Kónya, our CEO in DTITS. Laci, floor is yours for the first welcome speech.
Thank you very much. By 2026, confirmed Gartner, more than 80% of the enterprises will use an AI-based solution or service, and largely these will be based on open infrastructure. So that's Gartner prediction, and this means that also AI will drive up the need for open infrastructure, and events like this are more and more important. So we are really proud, as Zoli mentioned, that we can host the first OpenInfra Day in Hungary here in Budapest in our headquarters. Our company, Deutsche Telekom IT Solutions, is a subsidiary of Deutsche Telekom with 5,500 people. We deliver global services, IT, network, cybersecurity to DT and mainly its customers in the DACH region. Roughly 30–40% of these colleagues work in the cloud area or cloud-related services. And open infrastructure is a really important element of our services. OpenStack is the base technology for Open Telecom Cloud, which is DT's own cloud solution. It was, of course, further developed by Huawei and is mainly operated in Hungary by Zoli and his team. And we also use, later will be discussed today, the Kata Containers. We use also this technology, not only in OTC, but our other services, what we run in our hyperscalers area, as we deliver services for Microsoft Azure, Amazon, and Google Cloud as well. Looking forward to this day. I'm really proud that we have Alison today for the keynote speak and many other great presenters from Magyar Telekom, Deutsche Telekom IT Solutions, Huawei. I'm not listing now all the speakers today. Of course, we will not avoid AI, so you cannot go nowadays to any conference, not even IT, without mentioning AI. And there will be discussions about AIOps, which means, of course, automation, which means anomaly detection, which means predictive maintenance. And there will be also discussion about how AI impacts our work in the cloud services, in our cloud operations, meaning automated deployments, meaning dynamically scaled cloud resource usage, boosting innovation and cooperation, and of course, customized things. And just finishing my short intro, I wanted to share with you that I think there is one single area where AI is not performing that well yet. Any ideas which is that one? It's not my job because I will be eliminated by AI for sure. So in my view, AI is not working well in the stand-up comedy area. And you know why? Because its jokes are predictable. Okay, so with that, I hope that you will have not only nice learning day today, but also enjoy and have fun. Wish you a good day. Heading back to Zoli for moderating the session.
Thank you, Laci, for your motivating words. I'm not regarding who will be replaced by AI, but regarding this whole technology. And our next speaker will be Dániel Hegedűs from Magyar Telekom, chapter lead of cloud engineering. The floor is yours.
Thank you, Zoli. Hello and good morning, everyone. Yes, I'm Daniel from Magyar Telekom. I'm working as a cloud engineering chapter lead. And to be honest, I feel very honored and humbled at the same time that I can stand here today and speak to you on behalf of Magyar Telekom. Today, I wish to speak about the connection between open source and Magyar Telekom, and also me included. Magyar Telekom tends to have ambitious goals like digitalizing Hungary. Under the hood, my team actually contributes to this big goal by using open source infrastructure components. We are building platforms to applications that after that we are using our customers to connect with us. Since I mentioned platform, let me think about this conference as a platform as well, but for sharing knowledge, experiences, and ideas. It is a chance to connect like-minded individuals who are passionate about driving innovations and making a positive impact. So let us use the most of our time here. I encourage you to engage actively in discussions, to learn from each other, and I think it's a great opportunity to pave a better future, an open source driven future. I think I will cut my introduction short because I'm not the main event here. And thank you for being part of this experience.
Thank you, Daniel, for your words. And the third welcome speech is from Niels Magnus, Senior Cloud Architect and also co-organizer of OpenStack Europe. So, Niels, the floor is yours.
Thank you very much, Zoltan. So I have actually prepared some notes here because I want to give you some introduction to our today's event here. So welcome first, esteemed guests. I'm very happy to have you all here in this beautiful room. And my name is Niels Magnus, and I'm very honored to welcome you all here today on the behalf of the organizing team, which is a real international collaboration. That is because this OpenInfra Day is not just a single event, but part of a whole series of events taking place in Sweden, in Germany, in France, in Turkey. There is another one this week in Switzerland. And here, more or less, the concluding one in Budapest. We had in the past a number of more global events organized by the OpenInfra Foundation. But it turned out to have those global events has some minor drawbacks. So it is very expensive to go to places far away. It's not very environmentally friendly and so on. So about a year ago, I think, we had the idea, can we not create more regional events? And that is how the whole idea of a series of OpenInfra Days was born. So, and I'm very happy to see how this idea has evolved over the past couple of months, and to have you all here. But I'm not here to talk too much. I want also to do some housekeeping. And before we begin, I would like to address some notes to you. Let me see. So we have a code of conduct in place so that everybody feels welcome and safe in this place. I think this is important and also a standard. What else do we have here? We are streaming the event today, so warm welcome also to the colleagues and guests online. That is also important. We have a photographer around here, so for example over there. So if you don't have, or if you have any concerns of being photographed, just approach her and tell her about that. Something about times. We will have a couple of breaks and lots of refreshments, as you have probably seen already outside. So you can find the times for that in the schedule. We have also some nice lunch prepared, and that starts at 12 noon. The restrooms are just around the corner. That's easy to find. Wi-Fi passwords is probably something that you have received already. Otherwise, go to the colleagues at the registration desks. What else do we have here? Yeah, a big thank you. This is the slides, right? A big thank you goes to our various partners here on the event. There is, first of all, the OpenInfra Foundation. Thank you for your support and the trust in us in organizing all these events. Then there is the local organizer, Deutsche Telekom IT Solutions, they played a big and important role in making this actually happen, doing all the logistics, and preparing everything, as well as Telekom Magyar as well. We feel very honored to be here, your guests in this nice new campus. So I really was full of awe and to see how nice this all looks. And who else do we have here? As I said, we started as a small initiative, and this initiative we called OpenStack Europe, because it was a number of enthusiasts who had the idea of getting together and meeting from now and then we created for that, for example, a meetup group, and so the whole organizing team evolved in the first place. What else do we have here? Last but not least, a big thank you to all the organizing teams and supporting teams as well. So the colleagues from the audio and video, the colleagues from the registration desk, the colleagues who provide the food and the catering and so on. So you are all very invaluable. So I'd suggest to give a round of applause to those as well. Yeah, and I think, Zoltan, that's it. Should we turn now to our esteemed speakers? And I hand over the microphone back to you.
Thank you, Niels. Thank you, Niels. And we are very proud to have Alison Price from the foundation. She's the Vice President of Marketing and Community. Alison, yeah, welcome on board. And the floor is yours for the keynote.
Thank you. All right. First of all, I'm excited and honored to be here. But to echo what Nils was saying, I just want to thank the organizers. They do this, they volunteer to do this. It's done in their free time a lot of the time, and a lot goes into making this run smoothly. So thank y'all, and thank you to everyone who's attending. I love these regional events because we get to learn how some of the local users are adopting our software, and you can't really replace that. So today, I click fast. Okay, so today what I want to be talking about is OpenStack and how right now we're really seeing 3 trends that are driving a resurgence of interest in OpenStack that we're excited to see the global community rally behind. So to provide some background, so I'm with the OpenInfra Foundation as well as Thierry, who will be on a panel later. And if you're not familiar, the OpenInfra Foundation used to be called the OpenStack Foundation, but we host open source infrastructure projects, and we build communities around those, building developers, the users, and the ecosystem to really provide support to make these projects sustainable. OpenStack is one of our most popular, and a project that over the past now 14 years has gained a lot of adoption and a lot of interest from the ecosystem. But we're also seeing some increased interest around Kata Containers, which there's a talk about here today, as well as Starling X, Airship, and Zool. This cannot be done without the global ecosystem that supports the OpenInfra Foundation. As you can see, Telekom is here as well, but we have over 100 organizations who support our mission of building open source software communities that write software that runs in production. So thank you if you're employed by one of these organizations. We cannot do this without your support. And what have we done with that support? So, like I said, I'm going to be here talking about mainly OpenStack. And together, we've built a massive project that's one of the largest open source projects to ever exist. Over 600,000 changes, 10,000 contributors, which is something that's really unique in the open source space, and from hundreds of organizations. And just last year, we measured that OpenStack is deployed across 45 million cores of compute. And because it's open source, that's just what's reported to us. So we know that there's millions more of compute out there running on OpenStack. So if you're running OpenStack, please find me today, because I love to hear those stories and what you're doing with the software. But yes, so these three drivers that I'm going to be talking about are what we're seeing right now that's drawing increased demand across the global community of open source and infrastructure software. First one, which I'm glad would be here in Europe to be talking about this, is digital sovereignty. So digital sovereignty has really started to shake up what was considered the status quo of hyperscaler cloud and allowed for more regional focused clouds like Open Telecom Cloud to come in and create customized versions that are actually a little bit easier with the different regional requirements. This has been a massive opportunity for open source public clouds that are based on OpenStack. The second one was a little bit more recent, but Broadcom acquired VMware last year, and we have been receiving a lot of questions about, is OpenStack an alternative to VMware? The answer is yes, and we are seeing that demand all over the world. We get questions almost every day, and we've started working with some of the ecosystem companies in our community and have learned that over 60% have actually already migrated a user from VMware to OpenStack. Now, the feature parity is something that's not 100%, but that means that people are adopting a more cloud-native strategy, which is really exciting to see as they can be more innovative and work more quickly. The third one that has been mentioned already this morning and will be mentioned a lot more throughout the day is AI. So AI is redefining data center infrastructure, and this is the driver that I'm really going to zero in on today about how OpenStack is poised to really take advantage of this opportunity and how its benefits are actually going to make it the right software to run AI workloads. So the CEO of NVIDIA has been talking about the market opportunity behind AI. So the data center market was already $1 trillion, which is a lot of money. And they're expecting that to even double just because of AI and all of the unique requirements that AI places on data center infrastructure. For example, one of those is accelerated compute. So as everyone in this room is well aware, your infrastructure requirements are compute, storage, and networking. So if we're talking about accelerated compute, a new, more powerful compute needed for AI, we're talking about changes that need to be made throughout the infrastructure stack to be able to support that, from hardware to the infrastructure software and beyond. The other piece is storage. So because of the vast requirements of AI, storage requirements for infrastructure are going to skyrocket. So 180 zettabytes are going to be required to be stored by 2025 because just of this one use case. So this compute and the storage requirements are making us think that infrastructure needs to evolve. It needs to be different. And that's where open source is the best, because it can evolve because of the nature of the contributors that are building it, as well as the users who are operating it. So like I mentioned, these demands will require new hardware. So you're seeing NVIDIA, you're seeing next-gen, you're seeing a whole new variety of chips that are being introduced just to be able to support the, for the AI use case. But when you have new hardware, you can't use always existing infrastructure software to manage it. So you're going to see new software to manage that hardware. And that's where the global open source community, and particularly OpenStack, is already evolving the software to meet these demands. And this, I mentioned earlier, we're with the OpenInfra Foundation. The open source for infrastructure is what we do. It's there in the name. We are excited to be working already with developers and users to hear from the users and the ecosystem, what are these requirements? What are these things that organizations need to be able to run AI in production? And think of it from a software-first perspective. Then connect those organizations with the developers and say, as you're building the next 2, 3, 4 releases, this is how the software needs to evolve to match these demands to capitalize on this market opportunity. And I want to share an example of how we've done this before, because it seems crazy to think that we have $1 trillion market and this global open source ecosystem. Like, how are we actually going to make this work? So 10 years ago, this is actually my first OpenStack summit in Atlanta, Toby Ford from AT&T talked about network functions virtualization, or NFV. So as AT&T was a user of OpenStack, they talked about how the software needed to evolve to deliver what they needed for NFV. And AT&T is a massive telecom in the world, and they not only talked about their demands, but then they also worked directly with the developers to ensure that those demands were delivered in the software. And if you fast forward to today, 9 out of 10 telcos run their NFV workloads on OpenStack, which is something that we're really proud of. We work with a lot of them directly from all over the world, including in Europe, and it's something that we want to continue to see that opportunity build around. So that's how we did it. But step by step, we first gathered a coalition of key stakeholders. So we had AT&T in the room to talk about their usage requirements. But then we also got Nova developers. We got Neutron developers. We got all of the networking, storage, and compute engineers all in one room with AT&T as well as other global telcos to talk about what are the gaps in the current open source infrastructure that are preventing NFV from being production ready. So as those conversations were happening as part of step 2, they were able to create a roadmap and coordinate the upstream work in step 3 to actually make NFV production ready for telcos all around the world. And there's the slide I was looking for earlier. So now, 9 out of 10 of the world's largest telcos power their network with OpenStack, which I'm very proud to share. And it's just really showing how by applying those 3 steps, we can take advantage of that trillion-dollar market. Why can't we do it today with AI? And the answer is we are doing that with AI. And that's why I'm excited for events like this, to get everyone excited and to get people collaborating together to make sure that we can deliver AI powered by OpenStack in production. So when we talk about this collaboration, there's 3 groups that I've kind of mentioned throughout, and we call these the 3 forces. So you have the users like Open Telecom Cloud who consume the services, and they're running OpenStack-based products in production. You have the ecosystem who actually builds products based on the software and often employ developers so they can help coordinate upstream work to deliver the features that those companies need. And then you have the developers. So the 10,000 people I talked about earlier that have built OpenStack to this day, building those products, building those features, testing it, making sure it works, and then so that users can run it in production. So it's a very collaborative global effort. It's something that we're really proud to see continue to grow. Now, as we look forward to AI, as we coordinate this upstream work, one of the things that's laid the foundation is that we already have massive OpenStack adoption for HPC. And HPC, for high-performance compute, it really is similar to some of the demands that AI is starting to place when it comes to the increased compute, storage, and networking expectations. You can already see, we have universities all around the world, but one of the ones that we're really excited about is Stack HPC is actually working with Dawn Supercomputer, which is the UK's fastest supercomputer, to deliver AI workloads based on OpenStack. So this work is already happening. They have developers employed that contribute upstream, but they also just share those requirements with them. So you're seeing it from a user and a vendor perspective, seeing OpenStack already powering AI on a small scale. We're going to see that exponentially increase. NextGen, which is one of the largest purchasers of GPUs, I actually had a call with them last week, and OpenStack is the backbone of everything they do. And so they're very excited. They're based here in Europe, and they are going to be increasing their footprint significantly over the next few years, and we're going to begin telling that story so that they can get more involved in the community and that other organizations can learn from them and what they're doing with AI. But what's really cool is that, like I said, these features requests are often shared with the developers building the software. This is a demo that the PTL of Nova, the compute project, put together to show the live migration of vGPUs, which has been a long requested feature in OpenStack. And this was just released, last month? No, 2 months ago now that we're in June. So in April, this was released and one of the most highly anticipated features behind OpenStack Caracal. And we're expecting to see even more features be delivered so that OpenStack can really power these AI workloads. So if you're a contributor, thank you for all the work that you do because the software relies on you to evolve, and we can see it here on this demo in production. So really excited, and a thank you to Sylvain for putting this demo together. I did not. So to recap, so these 3 demands, digital sovereignty, and I think we have someone from Sovereign Cloud Stack speaking in a minute, so we'll probably hear about that a little bit more. The VMware changes and how those are impacting what people do for their virtualization or cloud native strategy, and the requirements that AI is putting on infrastructure are 3 massive drivers that are leading to a $1 trillion market opportunity for open infrastructure, and for everyone in this room, and for everyone around the world in the community. So I'm excited to share that with y'all today. And so we have this community of 110,000 community members across those 3 forces that I talked about: users, ecosystem, and developers that are coming together to collaborate and build the future of open infrastructure. So what I would invite everyone here to do is join us, because we can't do this alone. Every single person in this room has a role that plays into the evolution of software, into the evolution of open source, and of course, into the evolution of open source infrastructure software. And one really easy way here in Europe is we have a European hub called OpenInfra Europe. And this, I really do encourage everyone here to scan the QR code and join, as for certain challenges like digital sovereignty and the opportunities for OpenStack and open source infrastructure to really be relevant in those spaces. This group specifically is coming together. They're talking about things. The CRA has been a recent discussion that has been really popular among this group. But this is a great place to get engaged, talk about some of the regional things that may not be applicable to the global community, but that people here in Europe would be interested to collaborate around. So with that, I just want to say thank you. Again, if you're running OpenStack or Kata or any of those other projects, please come talk to me. I'd love to hear your stories, or just come say hi anyways. So thank you.
Yeah, thank you, Alison, for your motivating, exciting words. Yeah, and I think this was a very good introduction to our first presentation, because on the top of your slide, you mentioned digital sovereignty, which is a very topical issue these days in Europe. So in the title, we see SES, OCS, cryptic abbreviations, but they have something to do with digital sovereignty. So I give the stage to Alexander and Swaroop, yeah, from OSBA and Huawei, and they will, shed light on these abbreviations.
Yes, thank you very much. First of all, thanks a lot for the invitation. And while Swaroop is putting up the laptop, I'll just, I would like to say thanks that we can speak here about digital sovereignty. Yeah, that's true. That is the underlying motivation of both the sovereign cloud stack and the open services cloud projects. And why we have given this talk, a similar talk actually at the Eclipse Foundation summit last year. We've modified that a little bit because of a slightly different audience. But in a sense, why we are doing this is there are 2 independent projects, but they actually work well together, not only with the same ideal, but also practically, and that's what we would like to motivate a little bit today. So you're going to see also visually that there are 2 different presentations, but Ed will try to make a close link while we talk you through. So first of all, I need to switch this on. We have tested that, yes. I will talk about digital sovereignty as we understand it, and why we or how it motivates us to do what we are doing as the sovereign cloud stack community and as the open services cloud community. And then I'll talk about a little bit about the sovereign cloud stack itself. What are actually the deliverables? What we are trying to produce for outcomes actually, and why we want to do that. And then also finally why actually Sovereign Cloud Stack and Open Services Cloud work well together and follow the same idea before Swaroop is talking you through the Open Services Cloud. Now, we define actually three levels of digital sovereignty, and they are underlying concepts. Now, but first of all, there is a base layer of legal compliance. Now, that's actually not digital sovereignty, but it's the foundation for digital sovereignty. So if you're not legally compliant, then you probably won't make it, or you won't be accepted being digital sovereign. And legal compliance are basically, you need to follow the regulations, mainly data privacy and data protection, like the GDPR, or in the region where you are, which applies then, and other general standards. And that can be use case specific, right? Now the next level is what we call interoperability, and I talk a lot about interoperability, but in essence it means that you do have a choice. So, for example, you do have a choice which software to use, or which partner you work together with which implementation partner, right? Also, where your data are, how you can, do you have control of your data? Do you have a choice where to store the data and how to use the data? That's what we mean by that, and that is obviously the foundation of your own digital sovereignty. The next higher level is that you have the possibility to actually shape what you are doing, that you have the possibility also to modify that. For example, that you modify the software which you are using, and that you don't need to necessarily do on your own, but somebody do that on behalf of you. Okay, and if you do that, then you have reached the next level of digital sovereignty. And the top layer is competency, that you actually know what you're doing, and that you have full control of all the decisions which you make, and that's the hardest bit. And most of our customers actually don't have that and will never reach that, because that's not their core competence. They do something else, like I don't know, cars or washing machines or something else, right? But if you do that, if you have that, then you have you have reached the maximum level of digital sovereignty, and I'm coming to that in a second when we talk about the sovereign cloud set, that this matters, because our customers mainly, as general OpenStack customers, are data centers, right, and data center operators. Now, the sovereign cloud stack has been established 3 years ago and is funded by the Ministry of Economic Affairs in Germany, and the mission is to facilitate a community to enable digital sovereignty through mainly three outcomes or three deliverables, and those are what we call the 3 pillars of the sovereign cloud stack. And the number one is certifiable standards, and that is the most important and the most relevant one. So we ask our community to define those standards, and those standards must be able to be certified, and they can be certified, and I'm coming to that in a second. And that should enable interoperability, right? If you all work on the same standards, and very practical, you should be able to switch from one provider to another with respect to the standards which are applied. And the next one which we are doing, we actually create a reference implementation for a reference OpenStack implementation. So we create a distribution, but it's one, and we do that in order to prove that the standards which the community defines can actually be fulfilled, right? But that doesn't necessarily mean that that we want to exclude it. We want to include all other distributions, and there are many OpenStack distributions out there, right? But we need to prove, okay, these standards can actually be fulfilled. And the third one is that we want to encourage everyone in the community and even outside the community to actually collaborate and share knowledge. And that applies to the highest level of digital sovereignty, which is competency. So we want to enable users, people, to actually gain competency through sharing knowledge. And that materializes in different levels of certifications, which we are defining. So we talked about the first one, that is kind of the lowest layer, but it's not. It's only the foundation for digital sovereignty. The next one, and that is the most important, is a standards for interoperability, and that practically means that the cloud on the left side works largely reacts largely the same as the cloud on the right side. Okay, that's what it practically means, and those standards are in place, and they can be certified, and that's a simple script which is actually checking whether the cloud is configured according to the standards. It's that simple for the moment. The next one is that you do have a fully open stack with respect to your single components, right? So your SBOM is fully open. Now, any implementation can deliver that. Ours, of course, does that. Any other can. Often, it does not. That doesn't necessarily mean it is not interoperable. But the next level of, I have actually the ability to modify things, I have a fully transparency, would be a next higher level of digital sovereignty. And our reference implementation of course does that. If one component is not open source anymore, we need to find another one in order to provide the functionality. And the highest one is that also the operations which the data center operator does is largely open, and this provider is actually sharing this knowledge and collaborating with other providers in order to enable and to empower other people to actually do the utilization of the software. Now, we are here at the Infra. We are a guest of the OpenInfra Foundation. We do not develop software. We are taking software from the upstream communities and build an implementation. And many others do that. Huawei does that, and Telekom does that, and others. And we have a close collaboration with the upstream communities, of course. So we are actually supporters of those communities, and we're actually taking only the deliverables and trying to add that little bit of digital sovereignty which may be required. Now, I was thinking about explaining to you what is actually cloud computing, and that's what I did in the Eclipse Foundation. And I'm thinking I probably don't need to do this to this audience here. And nonetheless, before I go to the next slide, I'd like to have just some small principles, okay? So suppose you have a data center and that is a lot of physical resources, right? There's network and there's memory and CPUs and other stuff in there. And what the first thing what cloud computing needs to do is needs to virtualize those resources, okay? So they can be enabled and consumed in a different way. And then you have a top layer there. There's an identity management, and you need some APIs to actually access that and makes them able to use. And potentially you have some monitoring and perhaps a billing module or whatever, right? And once you have that, that's actually a cloud computing stack. Okay, so the software which is enabling that is a cloud computing stack, and once you have that, you can spin up virtual machines or other services, right? So a next level would be perhaps to have a container service or a stateless service or a Kubernetes. And on top of that, and that is also cloud computing, is advanced services like a database service, right? And that is very powerful in cloud computing too, that the users can actually just use the database. They don't need to care about any administration and configuration in the background anymore. That's also cloud computing. And why I'm saying that is it's also in a more practical sense. So when we go a level lower from the idealistic point of view, what that in practice means, and I'm putting up that chart here, what would mean digital sovereignty with respect to cloud computing in practical. And at the lowest level, I put up a sketch of the principle of a hyperscaler. And the hyperscaler, like Amazon or Google, is actually in a way a black box. Okay, so you actually don't you don't know what they're doing. You just consume the services. They have their own data centers, and they are closed, and they have their own development teams, and they're doing their cloud computing software. And very often, they also provide directly the services, right? So you're actually you're consuming that from the App Store. Now that is very convenient, and inside, it's very interoperable, but by far not outside. Once you are in this ecosystem, you largely stay in this ecosystem. So interoperability is not really given. Now the next one would be a proprietary, and like VMware. So two VMware clouds are largely interoperable, right? Again, in this ecosystem, it's working, but it's closed source. You can't look inside again. So that's not very sovereign either. And then we have a lot of OpenStack clouds, as Alison mentioned, but there are often individually configured, right? So they don't work the same. They don't act the same. So if they're not standardized, then interoperability, transparency is not an issue, depending on the single components, but interoperability is probably one. So what would be with respect to cloud computing a digital sovereign answer? And that is basically the mission of the sovereign cloud stack. So our vision is that we have a grid of different cloud computing resource providers, and there are, on the lowest level, interoperable because there are follow certain certified standards with respect to basically the configuration of the cloud computing stack. And the next one would be that these cloud providers open up which software they use and how they are being configured. And the next one would be that they actually work together, right? But it's not required that all of them reach all the levels. If they reach the level 1 and they are basically interoperable, well then that's fine, the grid is working. Okay, and there are different use cases and scenarios, as you can imagine. It's switching the provider, is having a multi-cloud strategy, is switching from a public back to a private, or from a private cloud to a public cloud, right? Or even having multi-cloud strategies with that. And certifiable standards or a standardized stack enhances that a lot. Now what is missing here, it's not really missing, I mean it's working, but you remember when I talked about hyperscalers, and they often provide services. Okay, and we do not have a service layer, and we don't intend to create one. Right? It's a large scope already. What the sovereign cloud stack does. Now the Open Services Cloud project does that. It provides a service layer. Now you can imagine both of these projects work independently, and they're meant to be. Okay, so we provide a standardized cloud computing stack or standards, and then a standardized implementation for that. And the Open Services Cloud works on I suppose any OpenStack in principle, and supposedly with others, but that is what's going to Swaroop is telling you in a minute more about that. But you can imagine that if you have a service layer, standardized service layer, and a standardized infrastructure layer, that it creates a moment of stability, which is particular, and that adds up to digital sovereignty for sure. And there are a variety of use cases which you can imagine. So when you think of this picture of this, we used to call it a virtual hyperscaler. I'm not so sure whether that is that's a good expression. But if you think of, you have different cloud service provider and you have an independent app store and saying, okay, I have this app, to which provider do you want to deploy this on, depending perhaps on the region, on the I don't know, ISO standard certification of the provider, or whether it's a governmental or a public one or a private one. That could be realized by that. You could also use the sovereign cloud, a data center run by sovereign cloud standard, a reference implementation, or even only by the standards, and the cloud service provider creates an own app store on its own and becomes, in a way, a hyperscaler with respect to their offering, right? You could also think of a software vendor which creates an app and then uses the open services cloud and together with the sovereign cloud stack and that infrastructure offering to provide services to their customers. And that's what I wanted to close with, because now we hear a lot more about the open services cloud, which is the second project which we want to introduce today. So.
Thank you, Alex. Yeah, so thanks for the perfect providing the segue to the next topic, Eclipse Expanse Open Services Cloud. So just reiterating what Alex told, SCS is about building standards across the infrastructure layer, and Open Services Cloud and Eclipse Expanse in specific is about building standards for the services layer. Right? So before we understand what Eclipse, get into details of our implementation, I would like to give a background on what Open Services Cloud is, or what the problem that it's trying to solve. Right? So today in the cloud services market, there are like two major problems. Right? One is the lock-in, which is more frequently spoken about, where a similar service is available on multiple clouds, but still they are not portable. Right? You cannot migrate from one service from one provider to the other provider, both service and data. Right? That's the lock-in. It's understood. The other is the lockout problem. Right? This is not so often spoken about, where the complete services ecosystem is locked out from the public clouds. Right? What it means is, today when you log into any public cloud provider, the services what you see in the catalog are the services from the cloud provider themselves. That means the cloud providers are also acting as software vendors. And these services are fully managed and fully native to the cloud provider. Means also in the console, you see they are completely integrated. They have better access to their billing or to their monitoring, right, to their logs. Right, it's fully native. Whereas as a third-party software vendor, when we want to offer services, the only one of the ways what they can use is via marketplaces, right? And in marketplaces, you see that you will have to bake your software in an image, right? So virtual machine image or a Docker image, right? And then it's again not fully managed and not completely native. That's one problem. And second is, there are no standards for marketplace, right? Every cloud provider has its own process and procedures behind marketplaces. So this means that a software vendor will have to then understand marketplace of each provider. So this is the second problem. Or if you use the other option of having their own SaaS portals, it's even more complex because they'll have to set up the complete process from provisioning the service up to the payments. It's even more complex, and again, still not native. Right? So these three problems, right? One, no standards for offering services. Second, there is no way currently to offer fully managed and native services. Right? And third is the portability problem. These are the three problems what OSC aims to solve. Right? That's the background of OSC. So what solution does OSC propose? Right? What OSC says is, so currently there are three main actors in the ecosystem: the vendor, software vendor, the service provider, cloud service provider, and the customer. So Open Service Cloud is suggesting to have one new layer in between the software vendor and the cloud service provider. On the northbound, we build standards, right, where there's one single way for software vendors to offer services across clouds. And on the southbound, we build integrations to all the APIs of this cloud service provider, right, all of their management APIs that is necessary to be configured to offer a fully native service. Right? And what happens in this constellation, at the end of the day, when service is offered in this way for customer, even these third-party services would be available as native services in their existing service catalogs. They need not, there is no, like one comes in a standard native catalog, and then in marketplace, there would be no difference. Right? Services are available in one single place. Right? So that's the idea of OSC. Right? So now comes Eclipse Expanse. So it's a project under Eclipse Foundation, under the Open Services Cloud group. Right? So if OSC had a solution, and Eclipse Expanse is one reference implementation of how this can be done. So when the solution for OSC was discussed and tabled, right, it was very clear that the most trickiest and the challenging part would be, of course, one is getting acceptance for the standards, and the second is about getting access to this internal APIs of the cloud provider, which can make services really native and fully managed. So what we thought is with Expanse is to start building these standards, and on the southbound, start implementing or integrating things that are already available, like use existing APIs, libraries, frameworks that can already build a pseudo native, fully managed services. And as and when there is acceptance for the standards and people understand the benefit that OSC brings to the table, then of course the cloud providers would be convinced to open up more and more APIs, and then eventually Expanse will be able to offer services that are really fully native and managed. So here you see the architecture at a very, very high level. Not all components are included. So similar to OSC, northbound is REST APIs, but here we are not only building APIs for the cloud provider, for software vendor, but also for everybody else. Like there's one single standard API for software vendors to offer their services and manage the lifecycle of a service in a catalog. And also cloud service providers can then monitor or see what services are running on them, on their cloud. And end users can even order services and manage the lifecycle, and administrators can administrate the complete stack. Right? On the southbound, what we do here is, for every cloud provider, we build a plugin. So this plugin is nothing but the integration to their APIs, to the cloud providers' APIs. So there's one, for currently we are building some, like for example, OpenStack is one of the plugins what we're building, where we're building integrations to the APIs that's already available. And the biggest difference here is, so the advantage between what OSC says and what Expanse does here is, if you package the APIs orchestrator and all plugins together, and you can run it outside any cloud provider, then it acts like a app play store, right? You can choose between service providers, cloud service providers where you want to offer services. Or if you just package the APIs, the orchestrator, and one single plugin, then you can just deploy this within the management layer of the cloud provider. Right? So both ways of both constellation is possible here. Okay, I will quickly switch to a quick demo. Yes. So one of the things what in Expanse we are building is a service description language. So this is a standard what we are trying to build, where a software vendor can describe its service using this description language. So for example, here there is a managed Kafka cluster being described here. It's a simple YAML file, right? I will just skim through only the fields that are interesting here, right? So it's for a cloud provider. Regio Cloud is one cloud provider in Germany, is running on SCS. So for them to offer a Kafka, managed Kafka cluster, there is, for example, it says which categories the service belongs to, what's the name of the service, a description, icon on which cloud provider type it is, right? And then on what regions they want to offer, and what billing modes, like fixed, and there is also pay-per-use, right? And service hosting type, they can either be self-hosted by the end users' cloud accounts, or it can be also vendor-hosted, like SaaS services. Then flavors are the T-shirt sizes of the service. Like for every flavor, there's a name and a lot of other pricing and other properties. And the important one is the deployment. For deploying the service, at this stage, we support Terraform, also OpenTofu for deploying the services. So when they say Terraform, for example, in this case, then the software vendor also will provide the deployer script either inline here or as a Git repo link, which will be then used to deploy, like create the resources and also install the software to create the service, right? And then we also have variables here where the software vendor then says like what inputs are needed from the customer, like what data is read from the environment, or what's a mandatory field, what's a secret field, things like that. There are a lot of other combinations possible here. So once this file is prepared, that means so this can be then used to register the service. Right? So I will use our expands UI component for the demo purpose. So all our services are exposed as REST APIs, but here I would just use the GUI, which is a very thin wrapper around the API for the so it becomes easier to explain. Right? So again, this UI is not a mandatory component. If cloud providers want to build their own UI, they of course do it similar to what we have done, or they can also change the styles to have the same look and feel of their consoles. So, and the GUI here is protected with OAuth, also the APIs. Again, optional in expands. If you say you want to use some other provider or some other authentication mechanism, it can be easily switched. So that's my VPN kicking in. Yeah, so I have here, my user is having all 4 roles. So this is a simple RBAC role what we have. Right. I will start with the ISV, that's the independent software vendor role. A software vendor can see, for example, in the catalog, what services he's already offering, right? For example, in the compute, in this case, I prepared some data for the demo. He says that he's offering a simple virtual machine on 4 different clouds, right? So he sees the details of it, and he can manage the complete life cycle. For example, he can update them, or he can unregister them, means remove it from the catalog, or he can re-register, delete. So it's fully possible. And we also have service policies implemented, which is the CNCF OPA project, probably have heard of, where the software vendor can then define some policies, and that would be validated before the service is deployed, right? Whether if the scripts are doing the right thing or no, right? And then credentials is for telling which accounts to be used for vendor hosted services. Right. And I use the register panel to register the service. So now I will just upload the file which I showed before. I already checked it out. So here the GUI just loads the YAML here, does no validation. It only sees whether the YAML syntax itself is valid, and just displays what needs to be, what would be sent to the backend. And now when I click on register, the request is sent to the backend, which validates this YAML against the service description language. And also it validates the Terraform script syntax as well. And then it's now submitted to CSP to check and approve this service. So again, the approval can be, it's optional. If you want to auto approve, it's also possible. So now until CSP approves it, the service is not available on the catalog. Right? So I just switch to CSP role where I can review my services. So I see that there's a new approval pending. Right? So here you can plug in any approval process you would like to. So I just say it's okay, and I approve this. So now I switch to the end user role. In the end user role, we see the end user sees the complete catalog, like what services he can consume. So this is the actual Play Store, so to say, right? So for example, for compute, he says, okay, there is a virtual machine service. I can click on that and he sees, okay, I can choose between the providers, right? And again, this complete GUI is all dynamically generated from the description language. There is no any hard coding, or the only hard coding here, to be fair, is the pricing bit, because that's still not implemented. The APIs are there, just the GUI part is hard coded. That's where you see the same price everywhere. Right? And then for the middleware, you see that now the new service is also available, right? What we had just registered, right? In my services, he can see all services he's already using on Expanse or via Expanse. And then in credentials, is configured what cloud accounts to be used for deploying the services. Policies, again, same the OPA policies. Even user level policies are supported. The user can also insert his own policies and they would be validated. Right? Workflows are for service migration. Right? So for the benefit of time, I will only deploy a simple virtual machine just to show how the deployment works. Right? I'll just pick one VM service, and I'll deploy it on Regio Cloud. And then, so this is a form also which is dynamically generated from the description language. I just say test demo and deploy it. So when the deployment runs, what happens is we also built some utility projects, also open source and Eclipse Foundation. For example, here is called Terraform Boot. It's an REST wrapper around Terraform. So what we do here is Expanse will simply hand over the deployment request to Terraform Boot, and Terraform Boot will then deploy it for us, and then hand over, like via webhooks, inform the Expanse back. So this helps us to scale Expanse and deployments in parallel, right? So these projects are completely independent, right? Can be used in any context, not Expanse specific. Similar to Terraform Boot, for OpenTofu, we made also something called as Tofu Maker. And for OPA, we made something called as Policy Man. So all are very generic projects, but used in Expanse. So deployment is still running. So this is our GitHub organization. Oh, sorry. So we don't have one mono project, so there is one project for each component in Expanse. So this was the project I was mentioning, Terraform Boot, and we have Policy Man. So yeah, so deployment is completed, and here you see what was the root password and what's the IP of the VM, right? And in my services, then the user can actually see that, okay, there's a service running, and then he can manage them completely. Like, for example, in the details, he can see that, like, what resources were created, right? And then there is in scale, he can change the service flavors. And similarly, modify parameter, he can modify the deploy variables, what was used. And then for migrate, he can migrate to a different service provider. Like, he can say whether he wants to change to a different region in the same provider or a different service provider. Then here he can choose, right, on which cloud he wants to go to now, right? And similarly, you can completely destroy the service. You can start, stop, restart, right? And for monitoring, I'm just using Huawei Cloud Service, because from Regio Cloud, the metrics API is still not there. But that's how monitoring would look like in Expanse. So this is how native you can build services using Expanse, right? And okay, the last option is last user role is admin role. So in admin role, you can see what systems are there in this current demo stack environment. So most of them are optional, right? They're not mandatory to be used. For example, the database, the reference implementation, MySQL, if you don't want, you can switch it to any SQL database. Open telemetry collector, again, you can disable it if you don't want. And if you enable it, you're free to forward this data to any hotel supported system. Right. What else? So we have our the project website as well with complete documentation. So we try to keep it as complete and detailed as possible. So feel free to have a look at it. And also the Expanse APIs are also on this Swagger Hub. In case you have any questions, you can also look there to see what APIs are currently implemented and supported here. So that's the demo. And yeah, the current features. So basically whatever I discussed now, it's again put together here. So interfaces, we have an API first approach. So everything is exposed as a REST API with Open API specifications. We have a UI component built, and we have a service description language, which we just saw, the YAML file. And we've also seen how a catalog is also built within. So catalog, to be noted, is here we are storing it in our own database. So if a cloud provider opens up their own catalog APIs, then the request would not go to our database, but it would be stored into the service provider's catalog. That's the key point there. And for services, so currently we are using the standard deployment tools, as we saw. We have Terraform, OpenTofu at the moment. The plan is to also, again, support Pulumi or Ansible in the future as the community grows. And also if, again, if the cloud provider says that they have their own custom deployment engine, and if it's opened up, then the plugins will have to be adapted accordingly to use that to deploy the services. Service metrics, we saw how the monitoring looks like. And the full service lifecycle, yes. So I showed you that we can, like, from deployment to destroy, migrate, start, stop, everything is possible. And we have plugins which separates each cloud provider's implementation, which also helps us to run Expanse in multiple constellations, right? From security, we have auth implemented, and cloud credentials concept added where to decide where to deploy the services. We have service policies based on OPA added. And observability, we saw that all the components in the stack develop like traces, metrics, logs on the hotel format, and you can push it to any system you would like to. Yeah, and the operating models, we saw that I mentioned you can use it as within a cloud provider's management layer or as an app store, right? It's possible in any shape and size. And also it can be used for any type of cloud. So it's not just, what we're building is not just for public clouds or private clouds, right? It's completely flexible. You can use it in whatever context you would like to. So what's the advantage that Eclipse Expanse brings when you work with SCS, right? So when you run Expanse on top of sovereign cloud stack, so the access to management APIs is easy, right? Because it's all open. So unlike hyperscalers, you don't know what they're using to offer their services, right? It's completely hidden. It's a black box, like Alex told. So in this case, the APIs are easy. So building a fully native service becomes as easy as possible, right? And then we have the power of community where we just write one plugin, right? And then it can be used for any SCS-based clouds. You don't have to write it for each cloud. Or write it once for OpenStack. You can use it for any OpenStack-based clouds. Same with service template. A software vendor will have to write a service template just once, and then he can use it on any supported SCS clouds. Again, the data and service portability just works out of the box because they're all having the same formats, right? So just as a background, this is the tech stack what we use in Expanse at the moment. So front end is written in TypeScript using React framework library, and then backend is on Java, Spring Boot, and a small part, like I mentioned, the Policy Man project is in Go. Right? And all our repos are on GitHub, open sourced, and it's governed by Eclipse Foundation. Yeah, so that's about Eclipse Expanse. And feel free to have a look at the repos if you like to. Thank you.
Swaroop, Alexander, these were really insightful presentations, and there we could see from theory and from the initial idea to the actual implementation, which was working. So there were no demo effects. So congratulations, working code, yeah. So that's and thank you for keeping the time for all the presenters. Now we will have a coffee break until 11. So yeah, you can drink dark coffee.
We
And
have one question from the internet audience. And thank you, Alexander, thank you, Swaroop, for your presentation. I was asked in the chat if I want to kick off one of those sovereignty projects. Is there one specific starting page that you would recommend to look up and to kickstart your projects? Especially from a perspective, I was reminded as a developer or cloud architect. Where should you go?
Yeah, I guess we need to have two answers because there are two projects. From the Sovereign Cloud Stack side, there is a docs page, docs.scs.community.
Okay.
And that is, as a developer, a very, very good starting point. And that's one of the deliverables of the Sovereign Cloud Stack, of course, that we do have and build and maintain a documentation, which is also a quite good OpenStack documentation, I believe.
It sounds awesome. Yeah. Okay.
And from expense side also, like I mentioned, we have our documentation, and it's also written in both perspectives. Also from developer perspective, when he wants to how to start adding a new plugin, how to extend plugins, and also from the software vendor perspective on how we can consume this service.
Okay.
So it's already in detail. So that should be good enough to start, I think.
Okay, thanks a lot. And now I won't prevent you from getting to the break. Thank you.
sure. So, as mentioned, we will meet at 11 back here. So after the dark coffee, there's a shimmering light of Sunbeam from Canonical. So it's waiting for you. Thank you. So next up on the agenda, we have project Sunbeam with Gábor Mészáros from Canonical. And it is under preparation, and the show will start quite soon. Yep, please take your seat. And hand it over to Gábor.
Thanks, Tony. Hey everyone, so my name is Gábor Mészáros. I am from Canonical, and I feel comfortable around my machine, so I'm going to show you a demo in a few slides, which is, unfortunately, I have to admit, is pre-recorded because I checked in this morning and my machine crashed, so I cannot log into that at this moment, but I'm going to show you the recording of yesterday. And so the whole aim of this project is to provide everyone a really easy entry to OpenStack installations. So it's important to know that this is governed by the OpenInfra Foundation. It is completely open source and essentially gives vanilla OpenStack deployment and installation using just automation from Canonical. What is the current challenge that we face with OpenStack? Just briefly, is, as I said, the entry barrier is super high, and a lot of components are around there, which doesn't necessarily meet the quality. So someone needs to maintain and select from those components. So ensure that they are repeatable, they can be deployed. So OpenStack is widely adopted, and it's increasing every year. From single, simple IT deployments to public clouds, private clouds, and also obviously telco clouds. It can also be used to host Kubernetes and like HPC uses as well. But this one, Sunbeam, is focusing also on the micro and single node deployments. And from there on, provide you an experience that you can apply on the previously mentioned use cases as well. So, as I said, it is not the easiest to run it and to operate it, but with the help of Sunbeam, these challenges will be are already addressed. All right, so we provide you an easy entry, and and also help you through the whole operations and the user experience, including upgrades, including security. So going from a single deployment, simple, small-scale one, we also provide security updates on the same stack for large-scale deployments as well. These are the components. So the separation of the control plane and the data plane or user plane is done by cloud-native components. So we use Kubernetes for the control plane. That can be run anywhere where you have access to, like on a VM or even bare metal. So you just need to have access to the data plane via networking. And the data plane itself is packaged in a format of snap, and that's the OpenStack hypervisor snap that you install just a single package on the compute host, and then you can start using the usual and regular OpenStack APIs, UI, etc. to drive your cloud. So as I said, you can decide and select where you run the control plane that consists of the like Horizon and all the other functions, Keystone, Nova, etc. And it can be split across availability zones easily. So the full AZ awareness is also part of the solution. When it comes to updates, it's quite seamless. We are using OCI images that are coming from ROCs, so ROCs images that are security checked, scanned, and patched on a frequent basis. How do you scale out and how do you run the software is done by these two components. So Canonical's MAS is taking care of the machine automation from discovery to commissioning, configuration of the storage and networking is done in an automated fashion. You can run it through pipelines or interact it with from the CLI. We are using Terraform in Sunbeam particularly to configure and run the automation steps from the installation and also for runtime deployments. And for the software configuration, we are using a few components. One of them is the Juju that runs software configuration and lifecycle management events. So those are the ones that when you need to upgrade the software stack or reconfigure the platform, you can use Juju and run it through kind of like a fully automated fashion. Let's see at the architecture from bird's view, right? So what we have for the management and the interactions with the client side, you just need OpenStack and Juju, two snaps that you can install literally anywhere. And the credentials are RBAC based, so you can also withdraw or provide access to any of your colleagues or any other, like interact with other data centers and deployments. From the control plane perspective, we are using Kubernetes to deploy and run all the components of the OpenStack control plane. That can be scaled out to a larger estate, but obviously if you want to use it for demo or development or prototyping, you can literally use the same environment and the same concepts that you would be running in your production clouds. So the control plane components are deployed on either a separate machine, or you can use aggregated or hyperconvert approach, and then you can put your data plane and the control plane on the same node or separate machines. When it comes to storage, our open source based choice is Ceph, which is prepended by microSAF. That only means that the packaging itself is done through the snap format. And then we have the monitors and the OSDs literally coming from the upstream releases. And then you can connect SAF to your OpenStack deployment, but you can also reuse and just use SAF for your other needs. So with the use of Juju, you can relate and connect these services to fit your need. So that means that in theory, if you want to deploy multiple OpenStacks next to each other, you can reuse any of these components and then just wire them as you see fit. As for the networking bit and the computing, they are packaged into this single package. That's the OpenStack hypervisor that I mentioned. And we have the Oven and Open vSwitch components there that you can interact with. So there are like CLI and API access to them, and they are just vanilla components. And the QEMU and Nova Compute are also running in the same snap, but they are running on the bare metal straight. So you have access to those configuration log files and everything there as regular configuration. This is the simplest use case in which you can have your environment up and running. I measured it yesterday, 32 minutes on a machine that has 4 cores, 16 gigs of RAM, and if everything aligns well. So I was playing safe game, so I recorded that, and I'm going to show you and speed up the deployment bits that are just stationary, and we would be just staring at the screen. But once it starts with installing the OpenStack client, you can continue with bootstrapping the machine and then configure it. There are a lot of tunables and options there, so you can provide a manifest file to run a custom deployment. That manifest file is literally a Terraform configuration in which you can select basically anything that you would anyways do in the other configuration formats. Multi-node deployment looks very almost identical. The only difference there is that you repeat the client installation and you just join the cluster with the token that you need to grab from the first node. And once that's done, you can run the cluster resize command to scale out the cluster. This one, so the multi-node deployment, is capable from 3 nodes up to 50 machines currently, but we're also working on a higher, wider scale deployments as well. And that's not the final option that you can run, but as I mentioned, using MAS, you can further automate the configuration for the physical machines. In the previous step, the challenge is that you still need to deploy your machine and configure and manage, secure, patch them. But with MAS and Juju combined on any nodes, you can directly, direct MAS to deploy the machines and use the OpenStack snap to run the rest of the commands. So the Juju commands are actually hidden, and you don't need to be super familiar with what Juju does. So in here, the complexity of OpenStack probably remains the same, but you have some help which significantly helps you bootstrapping and then running the full environment, including the upgrades. All right, so the interesting part starts now. Hopefully it will just go like smoothly. Or not. Okay, so as you see, it was yesterday, 3 p.m. and literally the commands I'm going through to install a single node environment. So in this case, don't expect any fancy commands, just as you see on the single unit deployment. The snap is installed. Actually, this is a virtual machine, so I'm running everything virtualized, and then probably that's the reason why it didn't survive the night. So once the snap is installed, you run this prepare script that is not doing too much, just creating that snap daemon group and generates the host keys that will be distributed across the rest of the environment. So that's also the same for multi-node clusters. The bootstrap command has the options to select the roles, and those roles can be the compute, the storage, and the controller node. And right, so in here, I didn't go with the automatic answers because I wanted to show you what options you have if you are going interactive. With the manifest file, you can even go further down below in the details. What's happening is the Juju Snap is being installed on this machine that was used for the client, right? So in this one, once it's the Juju agent is running on the machine within that snap, it will add the machine into the management of that model. So the construct of Juju looks like you have a controller, and that controller can interact with multiple models. And one model can be OpenStack, another model can be the observability stack, and these models can interact with each other. One model is typically one data center, right? So in this sense, I am deploying one data center that is named, I think, OpenStack, and then run the deployment from there on. You see that micro-K8s unit is being added to the machine. That means that we have to bootstrap a Kubernetes deployment somewhere. So that's also on the same machine. And once that is deployed, then we will be able to begin deploying the OpenStack components. Don't mind Microsoft here. I'm not using Microsoft, so that will be skipped. But literally the same phase would go through for all the scale that you run. I have already sped up to 10x the deployment, so to wait and deploy the control plane units. In this one, 29 of them, but on the more recent releases, we have more already built-in features, and also there is an add-on phase, or I'm not demoing that, but with add-ons you can also further expand the deployment with other upstream components. So as you see, compute and control are deployed, and that is the end of the bootstrapping phase. So that, I think, took about 20 or so minutes. The next one, if I why not? It's not going through, but the next one. Yeah, so why is it starting again? Sorry about that. I don't know why it's starting again. Okay, so the bootstrapping has completed. And now we will just look around the environment. So these are the snaps that were installed automatically by OpenStack, and that's the controller that we have in Juju. You can see there is the OpenStack model, and the status there will show the components from the Juju CLI perspective. Since it's not really interesting here to see what are the other details, I just left it with these few components. And within micro-K8s, so Kubernetes, you can see we have the other, the OpenStack namespace as well, and all the units are being deployed there inside Kubernetes. You have, if you see, there are like 2/2 of all of these. The reason for that is we have an operator deployed next to the actual workload pod or container within the pod, and we call it Pebble. So that's the application that's running and controlling the OpenStack components. So there you see that the image is called just charm, and in this one, glance API, and they are being fetched from the registry. If you were paying attention, it was actually running from Docker, the current installment. I don't know what's going on. So the current installment is coming from Docker, and that will be, in the next releases, moved over to the rocks images that I mentioned. Okay. This recording shows basically how to configure OpenStack in the newly deployed cluster, because it was not used before, right? So we need to create a user, we need to create a project that will be called demo, and we can start using it once everything is configured, like external networks and all the rest of the components. That's the step that shows or actually creates the tenant space. So this one is post-deployment configuration step. That's not strictly part of the initial deployment. From here on, you could change the values and run your custom deployment. So this is just for demo purposes, but you can run the configuration with proper production grade requirements. And obviously from here on, you can just use the OpenStack APIs and drive it as if it were any other OpenStack deployment. Right, so once this is done, I will just show a really simple use case of creating a VM, logging into it, and that's it. While it's happening, I just wanted to share with you that actually the debugging of a deployment can be done with usual Kubernetes commands, so you don't have to rely on like the snaps or anything else from that perspective. The charms will notice, and yeah, so the charms will pick up and accommodate to that changes. So the scale out can also be done from other like based on Terraform or other options. Okay, so what's happened in behind? The most time that takes is creating the overlay network and instruct Oven to deploy and like configure the bridges and so on. So I'm just pinging to see once the security groups gets applied and the machine boots up. I could like log into the console as well and then show the usual VM boot up from that output. So I just waited a few seconds to leave it, make sure to boot it up. Okay. The next and last presentation or a demo recording will show the use of the GUI, so you can also access the dashboard and get the details from Sunbeam. And as you see, this is not really responsive. So the reason for that is it's the power of the machine is not really enough to run a full OpenStack deployment. So obviously, it's recommended to not run it within a VM. But if you really need to, you can also have the same or repeat the same and then start developing or testing on that deployment. As for the customization, furthermore, like the UI, that's also doable, but the options there will have to be done and supplemented to the control plane via the snap configurations. Yeah, I just showed there that actually the UI is available, and naturally you have the usual commands that you can run. And add-ons wise, I will probably just jump from here. Good. Yeah, so if you go to microstack.run, you have the list of the add-ons there, and also a lot of guides and tutorials how to configure and how to further extend the capabilities of the deployment. What I wanted to share with you as well is that this one is though GA. I know that the charmed OpenStack current offering has much more, it's much more battle tested, and the team is working super hard to get the whole deployment on feature parity with the previous options. The challenge there is that we have to go through the plugin testing and integration, as well as you see there are these options like heat, designate, etc. So these components are being added one at a time and needs to be thoroughly tested. But if you have a simpler use case or just want to give it a kick, feel free to. And actually, the whole deployment is supported by Canonical. So if you have any issues, we are more than happy to help you with that. Not to mention the community that's behind the whole approach. Thank you, everyone. I don't know if you have any questions. Just find me. I will try to hide somewhere, so it will be a challenge. Yeah, I don't know if. Yeah, thank you.
I'm sorry, I'm not so familiar with OpenStack, but I have two questions. One question to
talk to the microphone, please.
One question concerning architecture. Why do you not use usual and broad usable tools like Terraform and like Ansible? Why do you use Juju and Mars? Because it's, from my point of view, it's a proprietary solution and not like Terraform and Ansible. It's the first question. And the second question is, you are deploying a cluster. And you have different nodes. Node 0, is it master node? Mm-hmm. Or yes, or is it a golden image on?
Yeah, let me respond to you. Thanks for the question. So basically, to answer the first question is why are we using Juju and not Ansible? The obvious answer is we are from Canonical, so we are not going to invest much in. We do, because that's open source, yes. Yep. You could do that, obviously. That's true. And to respond on the second one, so OpenTofu and Terraform is actually behind the deployment. So the configuration part is done with Terraform. So you can look at the schema files and the providers, and you can get all the like tunables and configuration from there and drive it through an external. I didn't show there the manifest that you can supplement to the command, so -m and your file. So that gives you a repeatable deployment experience. So reflecting on the MAS question, right? So MAS is actually open source, so that's the important bit. And the reason why we are using it because that's for us the best way to configure machines. So we could be using other options, other tools, but since this has been developed for at least 12, maybe 15 years, it is battle tested, and this is robust, and you can rely on it to drive your deployment. Regarding Juju, that gives you the operators, which are open source. You have access to the code base. You can contribute to the full pipeline in there and deployment facilities. And if you want, you can even run your own charms and configure your own environment with Juju, right? So these are actually open source components. They are not part of the OpenInfra Foundation, as like Sunbeam is. So that's I hope it answers your first part of your question. And what was the other? Sorry, the master node. Yes, so that's actually a client. So I try to put emphasis on it, that you can run that even from your laptop, from your mobile phone, whatever, that can run snaps. You can do that, even to that extent that you can destroy it and recreate it somewhere else. That is going to be a challenge because it's the whole system is not prepared for catastrophes like that. But the first node is the bootstrapper node, and that has the only concept of bootstrapping your cloud. And then the control plane can be executed and deployed anywhere else. So that's the Kubernetes part, which is running on micro-K8s, and then you can scale out, scale down the environment as you see fit. But the control node there, so sorry for the ambiguity there, the control node only requires OpenStack to access the CLI. Okay. Thank you. Any other questions? We are running a little bit late.
We have one more question from the internet. I checked in the chat.
Yeah.
And it was asked, it was stated first that Sunbeam is actually quite convenient to onboard new colleagues, for example,
yes,
to get them a personal version of OpenStack. But the question was, what is the long-term perspective of Canonical with the project? Is this meant to be, in the long run, a full-fledged production, ready for production use and for real private or public cloud deployments?
Yeah, thanks for the question. I don't know who asked it. To answer the question is yes. So Canonical is heavily investing and putting bets on OpenStack. That's why we are creating the new Sunbeam, or have created the new means of delivery, because this is cloud native and you can run production workloads in the same way in your home garage as is in public clouds, or even you can run this one on top of a public cloud. I don't know how much use for that would be, but for development, definitely I see the reason why that would have an interest.
Okay, thank you very much.
One more thing just to mention on that one. So we are running LTS versions, so releasing them. That's the long-term supported releases, which is 10 years support for the OS, and that can also be extended with the ESM support. So the OS part and then the deployment there is fully supported by Canonical. Thank you.
Okay, thanks.
Thank you, Gabor, for this very exciting presentation. Next up, we will have Balázs Bognár from Magyar Telekom, Cloud DevOps Engineer. Balázs, floor is yours, and we will hear about Ansible having a wedding with Terraform, yeah? So combining the two as an infrastructure as a code solution.
AWX as a wrapper, Terraform wrapper. Just give me a second, please. So, welcome everybody. I'm Balázs Bognár from the Magyar Telekom. I've been working here for 5 years as a cloud DevOps engineer. My main tasks are to maintain the infrastructure components, right now with Terraform and Ansible, and to operate Kubernetes clusters and the management and the maintaining of these clusters that we run. So, let's get started. A short summary of my agenda. So we will talk about the past, where we used VMware products to manage our infrastructures. We also will talk about the present, about how to manage our infrastructure with Terraform and AWX. And why can we call AWX as a Terraform wrapper? And in the end, I will show you a little short demo about managing the infrastructure with Terraform. So the past. In the past, we used VRA and VRO for different purposes. The VRA was, that is called vRealize automation, was used to cloning virtual machines from a so-called coding template. VRO, was used to make a post configuration on the newly created machines that was created by the VRA. In summary, it was good products, but for those who are strictly connected to VMware products, what we decided to not rely on and find an open source solution. And the question is, why we switch from that tools? Yeah, I mentioned that we would like to use open source tools, but of course there are different reasons why we started to find a new solution. These are so there was a requirement to use open source tools. The second, that if we use VMware products, we have a vendor logs, but we would like to use platform independent tools to manage our infrastructure. Actually, these tools have lots of functionalities, but we just use just some of them, and the others don't need for us. Of course, there was two so-called inconvenience with these two tools. These two was that the machine prefix numbers. So when we created the virtual machine, our so-called naming convents was so K8S with the letter that will represent that it is a worker node or whether a master node in our Kubernetes cluster, and there were 3 digits, which was the end of this convention that was these prefix numbers. And in the situation where you would like to recreate this virtual machine and assign the same IP address to this and the same networks, you have to manually go to the VRA and decrease these prefix numbers, so we cannot automate it, and it makes a little inconvenience sometimes. The other thing was that the EP pool reservations, so it's the same situation when you would like to recreate the VM, you have to reassign this pool, firstly disable it, and after re-enable it to be able to assign for this newly recreated virtual machine. And of course, there was another reason, the last but not the least important, the cost efficiency. Yes, and now the present. So we started to look for solutions, and we decided to use Terraform in the future, and right now we also use it. And we have 3 very important reasons why we choose Terraform. The first is infrastructure as a code methodology, which means that you can describe your whole infrastructure as a application code. The second was the code is stored in a version control system. In our case, it's GitLab, so we store our infrastructure code in our self-hosted GitLab instance. And the third part was to use a declarative tool. Operators prefers to use declarative language to imperative language, as we do, because we are operators. But the main reason or main goal was to handle multiple environments with the Terraform, and the code base is stored in a version control system. The first task, so-called task, was to design a solution where we have to design how to manage multiple environments with a single code and with the methodology of use the don't repeat yourself. So the variable precedence and the code-based structure was, here you can see a guideline. So there are different files that where you can define different variables, and the different variables will be applied during the creation. And the first file is a global.yaml, where you can define global variables, like it can be applied on the whole infrastructure, like it's site dependent, region dependent, it's not strictly connected to an environment. So here you have a file where you can define these variables, like, for example, time zone, which is, in our case, it's almost the same on every virtual machine. Another can be the template, if you would like to use the same template on your every Kubernetes clusters. The other is region.yaml. So if you maybe run on two sites or two different data center, you can define the name of the data center or the name of the cluster in region.yaml. And the third one is the environment.yaml. So for example, you have a non-prod environment, pre-prod or prod environment, and you can define in the environment YAML, for example, if actually, so basically your virtual machines run with 8 CPU and 16 gig of RAM. But what if that I would like to apply, it's on the prod cluster, I need 16 CPU and 32 gig of RAM. It's quite easy to do, because in the code-based structure, you have a possibility to define the environment YAML that, for example, I need 16 CPU and 32 gig of RAM. There's a so-called node role template, which means that in the Kubernetes cluster, we distinguish different roles for different purposes. There are the control planes ones and the worker ones, which can be, for example, tainted by different labels, and etc. etc. Here, with this file, you can define, for example, the taint for a type of role. For example, if you need a memory-intensive role, where you want to schedule memory-intensive applications, you have the possibility here to add a variable that defines the taint label, also the key and the value of it, and how should the taint will be applied on the Kubernetes node. And it's important that it's just a template, so it's applied on all of the environment. But of course, you have the possibility that, for example, misclick. So for example, you can define also this memory-intensive role in your prod environment, where, for example, the taint labels and keys are different than the other clusters also. So you have the possibility to do this. And last is, it's a unique configuration of a node, where you can create a file with the name, the desired name of the node. And here you can, for example, define the memory resources of it. Okay, so we designed the code-based structure, but of course there were difficulties, like in every proof of concept. The first, so right now, the state is that Terraform config is ready, and the variable precedence and the design seems to be okay. But the thing is that we can only create one environment, and we cannot handle multiple environments right now. And this is a big problem which we have to solve. And that is the time when the AWX comes in. So In this case, the Terraform offer or advise you to use some wrapper which makes you to able to manage multiple environments. Before we use AVX, of course, we made a comparison that you can see here. So we inspect the TerraGround, the TerraSpace, also the Terraform Enterprise. And here you can see we have some requirements that we have to sum up and make a decision after the comparison. The access control is only applicable for the AVX. Audit logging, of course, you can done it with Terraform to TerraSpace with a third-party tool, but actually we don't want to use any third-party tool. So that is the reason why just Terraform Enterprise and AVX can do it. Detailed documentation, if you see any documentation of these items, it's quite detailed. The AVX, you can see this sign here that actually the Terraform module and the Ansible, of course, have a detailed documentation, but nobody used before AWX as a Terraform wrapper, so that means this sign that you have to design it and try it on your own. Ability to manage multiple env, of course, that's what a wrapper do. Self-host, of course, every tool can be self-hosted. The graphical user interface, TerraSpace doesn't have any graphical user interface, as I know. It's CLI tools. Terraform Enterprise, of course, it has, and AVX also. But if I go further, free and open source tools are also was a requirement for us, which Terraform and TerraSpace are, and also AWX, but Terraform Enterprise not. And of course, it has a very high license cost. So overall, you can see the AVX on the score table. And that was the reason why we started to use it as a wrapper. But why can we call AVX as a wrapper? So it follows the dry code methodology, like I showed before in the variable precedence slide, the versioning. Versioning here means two things. The first, versioning of the modules. So with the AWX, you can do it with the template module of the Ansible. Like if you know where to put your manifest file, which is defined your module and your versions that you will use in your Terraform code, it's quite easy to make it with a variable. So you define a variable before you will run your Ansible code, and the template module will make this file and use that desired version of the module. The other thing is that AWX uses execution environments in a containerized environment that allow you to choose between these execution environments, and in the different execution environments, you can use different Terraform versions, or for example, OpenInfra versions also, if you would like to migrate to them. Authentication and authorization. You could see in the comparison table that AWX can solve this problem quite easily, because you can separate your users in different organizations, in different teams, which is provided by the AWX. It is used pure Terraform under the hood, and actually you don't have to learn any new commands like the TerraGround and TerraSpace, because the new commands will be the commands of the Ansible, which is we are familiar within the team. And last thing is high availability capability. So we run AVX as a service on 2 different Kubernetes cluster. So in that case, when one cluster is down, we can easily switch to the other AWX instance. We make a Terraform import, and after we can manage easily our infrastructure without any outage. And actually, after this, I think I can assume that it fits all of our requirements. And let the demo begin. So during the demo, I will show you, just give me a second, please, because the mirror is better for me. So in the morning, I created a new VM with the Terraform. Here you can see, I will show you in the inventory. So I created in the morning at almost 8:30 a new VM with the name that you can see here, with the IP, sorry. And you can see here in the vSphere GUI that actually it really exists right now. At first, sorry, just a moment. So here you can see that was the workflow job that I run in the morning. Here's we make a plan, and after we inspect the whole Terraform plan that shows us what will changed in the past, what we would like to see now, and what will happen in the future, you can make a manual approve to apply this Terraform configuration. And here, if I show you, the most important part will be here. Here, so here is the Terraform. Here you can see the module, create worker nodes run, and it's created one new VM that I showed you in the inventories, but it's also logged out. Yeah, crash, good. Yeah, so that is created. But right now, I would like to show you how to remove a virtual machine with also with the AWS and with the Terraform. So with the Terraform, we have a list.yml manifest file in every environment that defines the virtual machines that we would like to create with the desired IP configuration with, and the assigned networks, and network max has also the default gateway. So here in the morning, what I did exactly. So the only thing that I changed was that in here in the enabled was true, and I modified sorry, it was false and modified it to true. And after I started to run this Terraform work job that I showed you before. After the VM is created, and we are here now. But now we would like to remove this virtual machine. It happens quite easily. The only thing that I have to do is change it the false, this value. Here you can see that's the machine that I've created before. I make a git commit. And after, I will run a job template, which will actually remove the node, the worker node, from the Kubernetes cluster. After, it will remove from our CRM system. After that, it removed this A record from the DNS and the PTR record also. And last before it will remove from the vSphere. And the last thing that is will remove from the AWS inventory. So let's get started and see how does it really work. So if I search for OpenInfra, just not to mistype. Here you can see Terraform remove job template, specialized for the OpenInfra Date launch template. Here we change the skip confirmation to true, and here we can select the region where we would like to remove this node. Here we can choose the environment. Right now it is defined here in the Pro TST NSXT cluster, and here in the node section I have to list the name of the virtual machines that I would like to remove. So here that is the virtual machine that I've created before, but please double check. Yeah, that's it. Going to the next. Here you can make a short summarization about the environments that will be used, and I press on the launch. And here, of course, in the background, a AWS container will be created, which will pull the code from the GitLab, and it will run the defined Ansible code that is defined here and code and import the tasks. So here it will do the job in the background, but I will switch to that job. So here you can see it called the K8s remove node from prot_tst_nsxt cluster. It makes inventory update, like its gather facts and anything like that. And after it is done, it will run this remove node workflow template, and it will remove the Kubernetes node from the cluster. But we can check it also that here you can see that it still exists in our cluster, but after this job is succeeded, we can check it again, what we would not see in the Kubernetes cluster. But at that time, if you have any questions so far, please don't hesitate to ask. So you can see the job status is successful, and I also make the comment, and you cannot see here. After, if I switch back, it's also started another job templates that we run in the background, and here it is called the Terraform workflow. It's not to create, but actually it's just make a plan of it. And if I see the workflow Joe, which requires a manual approve, and if I see the plan here in the output, you will see that the plan is to destroy one node or one component, which is, if I scroll up, it is our worker node. And yeah, that's what we would like to do. I approve it. And if I go back and see also the vSphere, and also here, and some moments later, you will see that the virtual machine will be shut down and it will be removed from the inventory also. Yeah. So AWS started a guest host shutdown, and yeah, it deleted the virtual machine. And if I reload the output, it was successful. And if we see the inventories, it's not here. So it's the end of the demo, and also it's the end of my presentation. So thank you for your kind attention. And if you have any further questions, please ask.
I have also a microphone here if anybody has a question here directly in the room. I would like to ask one question also about long-term strategy. So you talked a lot about Terraform. There has been some changes in licensing in Terraform recently. How does this affect your adoption in your projects? And have you already thought about alternatives potentially?
Alternatives, yeah, maybe we can call it as an alternative, but we would like to switch to OpenTofu, which actually I tested it 2 or 3 weeks ago, and it was quite easy to implement because the only thing that I had to do was to switch the execution environment, which contains the OpenTofu binary that we run, and if I just give me a moment and I will show you that where you defined to call the Terraform in the Ansible module, you have a possibility to give the path of the binaries that you will call. And no.
Now it's back.
Yeah. Great. So
yeah, I'm pretty sure it's somewhere in there. So you have good faith that the API, if you say so, or the CLI interface stays the same.
Yes, and I think that's the project path. I think that, but I'm not totally sure. But yeah, so the only thing that you have to do is just give the path of the binaries that you will call, because if you check the code of the module, it doesn't require to be a Terraform, actually, because the OpenTofu binaries and the Terraform binaries use the same arguments, so it's quite easy to switch to that.
You're sure that will stay so in the future?
Yeah, I think.
Okay. Then one more question.
I'm impressed that you have done a good job. You have divided your code, Terraform code, in different YAML files, global, regional, machine dependent. My question is, did you try to deploy environment in different hyperscalers? Terraform makes it possible to deploy AWS plus Google in parallel. Did you try to do it?
So far,
it could be a step direction standardization. What was our conference?
Yes, you're absolutely right, but we don't try it right now. But of course, we have a vision about maybe try it. And also I think about that how maybe can we use AWS Terraform when we would like to use a hyperscaler in the background and manage with the Terraform. And I think yes, but need some modification for the Terraform code and the Ansible modules, for example, how to solve that you have multiple accounts that you would like to manage in the AWS. AWS. And so yeah, I think there's some tasks to do if we would like to move to a hyperscaler, but it's not an impossible thing to do.
Okay, then thank you very much. Thank you for your presentation.
Thank you for the opportunity.
Thank you for the insights.
Yeah, and Balázs mentioned the tofu. Yeah, it's not on the menu, but you will find other, and we will meet in an hour and continue the conference. Thank you. Yeah, Adam, I don't envy you because right now you will have to fight against the food coma with this topic AIOps. But I think it will be very interesting. I already saw a preview about this presentation, and it will be fun and exciting. Adam, floor is yours.
Thank you very much. Could it be that we found the solution to all the problems we already had in IT operations? We found the silver bullet. And this divine solution is called AIOps. Or, if we look at it from a slightly different perspective, we realize that it's nothing more than just a simple rubber ducky. Hi, and good afternoon, everyone. Thank you very much for being here, and I hope you had a good lunch. In this regard, I have good news for you, because this is going to be a digestive session, meaning no code snippets, no low-level designs, only stories, histories, ideas. And at the end, I hope you will also gain some inspiration. My name is Adam. I work as a product owner for Open Telekom Cloud. You know, the largest OpenStack-based cloud in Europe. I'm very excited to be here, and I'm going to talk about AIOps. Let's make it clear. This is not a product pitch, meaning I will not mention any specific product or vendor. Because once you know what you are looking for, you will easily find it. But if you don't know the direction, it will be not easy for you. Today, first, we will look at artificial intelligence in general and how it may affect our daily lives. Then, we will look at the ways how artificial intelligence can affect our lives. We will take a look at the current state of IT operations. Then we will jump straight to the most important part of this presentation, because the definition of AIOps will be revealed. There will be some skeptical voices, and to calm down those skeptical voices, I will take you on a trip. We will travel back in time, and we will see the origins of artificial intelligence and IT operations. We will touch some of the most important milestones, and we will see how this area developed until we reach the present days. Once we reach the present days, we will take a deep dive into AIOps. We will learn about the foundations. We will see how an AIOps system is built up and how an AIOps process works. Once we know that, we will look at some real-life use cases, how AIOps can be utilized, and how AIOps can help you during your day-to-day operational tasks. And at the end, bless you, at the end of this presentation, we will raise our eyesight and we will look into the far future to see what are the future possibilities of AIOps. We will look at market data and we will look at some predictions. So with that said, I would say, let's get started. Let me put this little fella here, and let me ask you a question first. Who is familiar with AIOps? Who heard about AIOps? Okay, that's good to see. And who of you is brave enough to say, yes, this is something we are using in our daily operations in our organization? Okay. We have somebody. I hope you will also find this interesting. Okay, I hope this will change by the end of this presentation. As I said, let's start with artificial intelligence in general. We heard about this from many sources that, oh my God, AI will come and will take over our job. This is something really have to be afraid of. This is something that will happen, especially in IT operations. Automations are ongoing. More and more tasks are automated, and we, human, maybe become obsolete. Is it reality? Will it happen? To be honest, I don't know. But to have a better understanding of this situation, I came across a future report, which was published by IBM. And there is a very good quote describing this entire situation. And it's the following. AI will not replace people, but people who do not use AI will be replaced by people who do. And I think this is the quote that describes the best this current situation. So I also believe AI will not come and take over. It depends on us. And it depends on us whether we are willing to learn or not. What is the situation in IT operations? Do we really need artificial intelligence? Or maybe everything is fine the way it is? How about asking someone who already works in this area, has quite a few years of experience, and can give us an honest opinion how life in IT operation works? So let's meet Andrew, who's 32 years old and works in IT operations. You see, Andrew can give us an honest opinion. What is life in IT operations? Look at this slide. Just imagine, this is the one and only slide you have about IT operations. And you would feed this to your AI. What would be the message your AI would understand from this? What if you would ask, hey, AI, tell me, how is it like to work in IT operations? What would be the answer? Around 1 week or slightly more ago, when Google released the AI-powered search engine, there was a user who asked this search engine a very simple question. Okay, how can I prevent my cheese from slipping from my pizza. And the AI was very helpful and provided an answer. Well, it was a slightly unconventional recipe which contained glue. Of course, if you add glue to your pizza sauce, it will not slip. But how was this possible? How is it possible that the AI found this solution? Very easy. As it turned out, 11 years ago, a Reddit user posted this as a joke. So it looks like our AI doesn't have a sense of humor. But let's come back to AIOps. Actually, I did a quite stupid but surprisingly effective method research on the topic, and my research methodology was, I simply put it into Google Trends. And why am I saying that it was surprisingly effective? Because it clearly shows the beginning of interest towards this topic, which is somewhere at the end of 2016, beginning of 2017. If you look at publications in this topic, some of them may say 2016, some of them may say 2017, but actually it's 2016. Why? What happened in 2016? So there's a company, Gartner. You already heard about them. You know, they are quite famous for their 2x2 matrices, the Magic Quadrants. Anyway, they published a paper in 2016, and that was the first time in history when the term AIOps was used. And Gartner was kind enough not only provide us with this term, but also Gartner provided a definition as well. As a professional presenter, I will read it out loud. So AIOps combines big data and machine learning to automate IT operations processes, including event correlation, anomaly detection, and causality determination. So far, so good. A few months ago, I was talking to my friend, who also happens to work in IT. And I was quite enthusiastic about this. And I was like, yo, man, I'm going to have this presentation about AIOps. That's so cool. And he was like, AIOps? Never heard of it. I don't know what is it. Adam, can you summarize this in 8 seconds so I'm not wasting too much time on it? So the guy also happens to work in upper management, so I think this kind of behavior is like acceptable. And I was like, yeah, of course, man. You take all the data produced during IT operations, and you apply the power of big data. You apply machine learning, and you will have the event correlation. You have the root cause analysis, the pattern recognition, whatever you can just imagine. And he was like, yeah, but actually, isn't this something that we are already doing just with an AI sticker on it? And I think the guy made a very good point, because if you look at the definition, you may have this gut feeling that, come on, that sounds so familiar, that there's nothing new in it. But still, why is it there? Why we are dealing with this? So I tried to continue this conversation, and I gave the most sophisticated answer possible to this, which was like, well, yes, but actually no. So let's see, why yes? Why do we have the feeling that this is nothing new? And why no? What is new in it? And to have a better understanding of this, let's go back in time. Let's see the origins of artificial intelligence and IT operations. The entire story and the history is extremely long. Also, it's very interesting, but we don't have too much time, so I will only touch some important milestones, which I think has something to do with the artificial intelligence and IT operations together. First things first, where is this term artificial intelligence coming from? And it was designed in 1956 by John McCarthy. Why am I showing this to you? Because probably you know about it, and there were so many other big minds behind this, like Alan Turing, Claude Shannon, and so on and so forth. Because John McCarthy also provided us with his definition of artificial intelligence. And it says, the science and engineering of making intelligent machines. So it's basically a science. Usually we have the tendency to give too much power to artificial intelligence and treat it as like a supernatural being or something. But Let's be honest. And let's come to the ground. This is just science. So what happened next? In the 1960s, there was a huge enthusiasm toward artificial intelligence. And not only was this enthusiasm big, but the belief in this entire thing was so huge. Some of the researchers even had the idea that creating human-like machines is just over the corner. And it was in the 1960s. Can you imagine? There was no computing power available. There was no storage, nothing. But still, the mind, the idea was there. And that was enough to start funding the projects which were promising things like this. And one of those systems were the expert systems in the 1970s. What is an expert system? An expert system is a computer system emulating the decision-making ability of a human expert. Don't forget, we are in the 1970s, and still people were, okay, yeah, according to the script. So people were already thinking of machines, and the promise was really huge. Those expert systems were domain-based, like domain-logged systems, and those were actually built up on a basis of if-then-else clauses. And of course, if you put a lot of them after each other, you will have a huge decision tree which may or may not give you a good answer to a different question. Okay, the first expert system was designed in 1965, but interesting things, those expert systems were still used until the 1990s. Why? We will come back to this later. There were also limitations to this expert systems, as I mentioned, scope, adaptability, and it was hard-coded. So whenever you wanted to change something in the decision tree, it was not really easy. So it was not really delivering. Let's move on in time. In the 80s and 90s, finally, we have something like the network management system. What is interesting is why are those network management systems interesting? Because finally, we have interconnected computers, and we started to collect data to represent the current state of our IT infrastructure. So finally, we had some basic monitoring data. We could finally identify on a basic level the outages, and finally we could generate some alerts. This provided a central view, and it was very basic, but compared to what we had before, it was revolutionary. Of course, the system also had its limitations. There was basically no resource to deal with the amount of data it created. So obviously, those systems were limited by the analysis capabilities. Same comes with handling the complex events. The computing power was simply not there to do the complex analysis. And at that time, the automation was on a very basic level. We need to talk about AI winters. And yes, those are called like this. What were AI winters? As I mentioned, in the 1960s, there was this huge enthusiasm and optimism towards AI projects. But after a few years, the founding bodies realized that we have only promises, but guys, you are not delivering. Enough is enough, so funding is cut, no more funding. So far in the history, there were two AI winters. One was from 1974, and the other was from 1987. The reason I'm showing this to you, because if you look around, obviously, right now we have an AI summer. Everybody is happy about AI. But will this last forever? Are we sure that it will go on indefinitely? Or maybe we can expect another AI winter. We don't know. There are some researchers saying that there's a probability for a next AI winter as well. Okay, let's move in time, because all the good things started to happen in the 2000s. Of course, we are talking about a time when the dot-com bubble already bursted, but still, we gained some more traction. I'm putting AIOps here in quotation marks for a very simple reason. As you learned, At that time, we didn't know how it is called because we needed to wait until 2016 when Gartner came up with the idea of how to call this. In the 2000s, there was this phenomena called the data tsunami, because suddenly there were so many devices creating so much data. Something had to be done. We needed a brand new concept to handle the large amount of data. We needed a paradigm shift. And that was the time when the era of big data started, when finally we started to think about how to handle the large amount of data which was available at that time. And that's where we can say that the AIOps was born, because with this complexity, with this amount of data, we needed a brand new approach in IT operations. And we can say that that was the first time when we started to think about a new way how to approach IT operations. But still, we didn't know how it is called. We just had the gut feeling, maybe we can apply the power of big data and machine learning to IT operations. Also, with the same thing, the machine learning started to grow, and it was also introduced with the big data itself. Here, I think we need to talk about MLOps as well, because as we learned, AIOps is basically artificial intelligence and IT operations combined. And you may also think that MLOps is nothing more than machine learning and IT operations combined, which is not true. MLOps is the further development of DevOps, where machine learning and the DevOps cycle are combined. And MLOps is basically the full lifecycle process of delivering machine learning models into the market. And I just want to spend a few seconds on that to show you how an MLOps process looks like. So you see on the right side the classic DevOps cycle, which is extended by the ML machine learning additions, where you have things which you didn't have in DevOps as an input, like data and the model. So that's it about this. Let's move forward, because now we are getting closer to today. And now we arrived to the 2010s, where basically we had everything in place which allows AIOps to shine, to rise. Now we have all the automation. Now we have deep learning, and we start to experiment with this in more and more projects. So let's see what we have so far, where we are, what we learned. Okay, as you remember, 1960s, there was this huge enthusiasm towards AI. Then came the expert systems, then the network management system, big data learning. 2010s, we have cloud automation, deep learning, eternal happiness. Until we wait for 2016, where Gartner finally came with the term AIOps. Why did my friend have the feeling that this is something we are already doing? It's very easy. You see, from the 2000s, we already started to think towards this direction, but at that time, we didn't know how it's called. It's very easy. So that's why you may have the feeling that there's nothing new. But still, there is new, because since then, the artificial intelligence technologies, the machine learning, the deep learning, developed to a much, much advanced level. So now we arrived at the point where we can start talking about the AIOps Foundation and how an AIOps system is built up. Here you can, to put it into context, so compared to traditional monitoring approaches and the operational approaches, AIOps is a continuous insight. So it's not something that runs once, it's something that will run continuously. We will look at this after a few slides. So what are the main steps of an AIOps systems? First, you need data. But to be able to collect this data, you have to make sure that it's in a state where it can be observed. Meaning, if you are not measuring something, you have to measure. If you don't have sensors installed, you have to install sensors and so on and so forth to make sure that you are able to collect the data. The next step is obviously the ingesting, collecting, and storing. Here you have to also make sure that you have enough resources available to store all this data. The important thing in AIOps is that you are collecting data not only from one data source, but from as many data sources as possible. Because if you have data from many data sources, from different sources like not only the IT monitoring system, the health check data, the operational systems health check, but you can also combine the data coming from business. So your machine learning can identify anomalies much easier and can come up with solutions you were not even thinking of. Okay, so the next step after ingesting is the querying and the mining of the data. And here is the part when you apply the power of machine learning and big data analysis. And at the end, you will get the results, and you will decide what to do with those results. Let's take a look at the platform strategy of AIOps. This chart is coming from Gartner as well as many other things, because Gartner is doing a pretty good job in shaping the industry. And if you look at their future reports, sometimes it makes the impression that basically they are writing self-fulfilling prophecies. But it's only my opinion. Okay, coming back to the AIOps platform strategy, we have three important elements. We have observe, engage, and act. Observe means you are checking the data. You are monitoring the data, and here you are collecting everything you can have to put together. Bless you. Machine learning, predictive analysis, and I had historical data. So the first step is observing, as I mentioned, and then will be the engage. Because once we have the data, we can make decisions how to handle the results coming from the monitoring. And the last step is acting. And that is basically, I think, the most interesting and tricky part. Because it depends on your organization, how much power are you willing to give your system to perform auto-remediation or to perform automatic changes in your environment based on results coming from your machine learning and the AI results. And this is also part of the connection with your IT service management system. Okay, enough of that. Let's see how AIOps works in action. Let's check some real-world use cases. And you know, today it's pretty easy to sell anything if you just put an AI sticker on it. So this is an AI-powered pen. Everybody would give their money just to get it. Okay. So I brought here three important metrics. Of course, the list of metrics can be much bigger. Especially if you work in IT operations, you are aware of this metrics. But here I brought only three of them: the incident resolution time, the mean time to detection, and to mean time between failures. And I want to show you with examples, of course, imaginary examples, how AIOps can improve those metrics. So let's see the first example, which is the incident resolution time. So let's say we have an e-commerce platform, and the classic example happens that there is a surge in traffic, so your application obviously crashes. Users are unhappy, business is not happy, because you are using not only customers, you are using money. Customers decide to spend their money somewhere else. So what is the traditional approach in this case? You have an IT department, and hopefully there are some tickets generated by your backend, by your operational teams, because the worst thing that could happen, you will get the tickets from the customer. If that happens, you know you did something wrong on your operational side. Then your IT colleagues start to analyze the log files. This is a manual, very, very long process. And during this, you are wasting time, and with this, you are wasting money as well. But what happens if you have AIOps? So AIOps already has the historical data. You can apply the machine learning, and it will automatically detect the crash of a given application. And it can also detect why it happens, because based on the historical data, your AI can go through everything and find the correlations, what happened in the past and what was the reason for that. And there are more options regarding this. For instance, you can give the power to AIOps to start the auto-remediation. As I mentioned, it depends on your organization, how much power are you willing to give. But based on this historical data, your AIOps can start to do the auto-remediation. And what is very interesting in this part is that your AIOps, even if it tried to do the auto-remediation and it was not successful, it will collect all the data for your IT people to make a final decision. And they no longer have to spend their time to collect the log files. AIOps will provide them with a decision preparation. So again, you can gain some time. Let's see. Meantime to detect. Let's say you have a hospital, and there is a remote wing of a hospital, and there is a switch which is misbehaving. That causes intermittent connection problems and also connection problems with the medical devices. What is the traditional approach? What would happen? So again, if you have an institution like this, you probably have an IT department somewhere in the basement. You can call them, and if you are lucky enough and they pick up, they will say, "Hello, IT, have you tried switch it off and on again?" So that's the classic approach. And you know how it goes with a traditional IT approach. Sometimes they will get tickets, sometimes they not. The worst thing when there are no tickets, because this switch is somewhere hidden remotely, nobody really uses it, and nobody cares. Whether it's blinking or not, doesn't matter. But once it becomes important, turns out, oh, this switch was not working. And we know that. We've been all there, so we know how it looks like. Let's see how it would look like if we had AIOps. We had the real-time monitoring. As you remember, AIOps is a continuous cycle. So it's not like we are waiting for some alerts, for some triggers, for some thresholds to be overtaken. But there will be the real-time monitoring. As we learned previously, we would have the anomaly detection, the early warning, and finally the root cause analysis. Because we are collecting data from many data sources, the causalities can be identified by your AI system. You no longer have to spend valuable time on analyzing your log files. So that's how you can improve the mean time to detect. Let's see, what about mean time between failures? Let's say we have a data center. As usual, the data center runs critical applications. What is the traditional approach? And I'm talking about very simplistic things. It's oversimplified. So for those of us who are working in a data center, we obviously know it's not exactly like this. This is an imaginary scenario. So we have the reactive maintenance, meaning the maintenances are scheduled. So for instance, every 10th of the month, we will open a maintenance window and we will do the necessary maintenance. And because of that, our IT teams is relying heavily on the monitoring tools. And because of those monitoring tools may not be set up correctly, so it may happen that not all the problems will be identified using the monitoring system. But what if we had AIOps? And I think it sounds like I'm repeating myself, but I wanted to help you to put this thing into perspective to see how you can utilize the power of AIOps and what does it mean, an AIOps-based and powered system compared to a traditional system. Because here, as I mentioned, you have data from separate data sources, and you can collect all this data to have historical data. And because of the power of AI, you will have the advanced analysis, and based on this, you will be able to do magic things like the predictive analysis. Usually, when something goes wrong, you will get an alarm once a threshold is passed. And once it happens, you know that there's a serious problem. But what if you have a predictive maintenance alert? It would say, this system started to misbehave and started to go into a wrong direction. So far, the alarm threshold is not crossed. But if it continues for the next 2 hours, it will definitely be crossed and the alarm will be triggered. So you will have the opportunity to make a decision before the alarm threshold is reached. And this gives you a huge advantage, because it's not like suddenly you get an alarm and, oh my God, something went wrong. But something may go wrong. And then you can jump in and to start the correction steps even before the disaster happens, or hopefully it never happens. Let's take a look at an imaginary retail chain. For some reason, it's called Ducky. I really don't know why, but let's believe that that's the reason. So we have this retail chain with many stores in the country, and they are preparing for the Black Friday. I don't know how many of you had the chance to work for an organization which was hosting an e-commerce platform. So Black Friday always meant looking like Andrew at the age of 25. Because you know something will happen, and you know that something will go wrong. And you have management, they have high expectations, especially towards the IT, because the expectation is to provide a stable business platform so you will not lose a single penny. But what if you don't know what is your system capable of? Traditionally, what would your IT people do? You know, the fear that you have is the potential bottleneck that suddenly everybody wants to buy from your store. So you will encounter unimaginable amounts of visitors on your site. And you don't know how much more. Only thing you are sure of that it will be much more. But how much? You don't know. So traditionally, what would the traditional IT folks do? Stress testing. You run a stress test and you try to push the limits of your system, and you can say, okay, seems like after you reach like 20 million visitors, your system starts to degrade, and so on and so forth. But what can you do with this number? You don't know if you ever will reach the 20 million. The only thing you know that based on the stress test, your system will start to degrade. So what can you say to your management? We have to upscale so we can handle 20 million, but is this really needed? Because if it's not met, your threshold will be only like 5 million. You wasted a lot of money on resources. So you need to be somehow realistic in this case. But what if you have AIOps? So you already have historical data. So you can compare, okay, we already had 6, 7, 8, 9, 10 Black Fridays. We have all the data from these events. Now we can do some prediction, what may happen in the future based on your machine learning. And once you were able to do the prediction, you can utilize the resources in a smarter way. But it doesn't mean you limit yourself to the resource utilization. It means you can start off with a much predictable amount of resources. Of course, you can always extend this, but at least you are not wasting money for the entire time of the Black Friday. You will have the real-time monitoring, we already talked about it, and the automated scaling, which in this case is much smarter because your insight and your prediction is based on data coming from your machine learning. If you have AIOps in place, very easy. Everybody will be happy. So happy customers, happy management, and what is important, after such an experiment, and after one time AIOps proved to be successful, you can rely on it, and the next time, and the good thing about this is as time goes on, you will have more and more data, and your predictions will be more and more precise because the more and more historical data will be available for you. Let's take a look at the future of AIOps. Again, Gartner, in their future report, which is dated 2022. And why am I using the future report of 2022? For a very simple reason, because that was the last future report where they mentioned AIOps by name. As we heard in the morning, the future report from 2024 mentioned that AI is something that must be included in every company's strategy. So it's like a much wider prediction. But here it was clearly said by Gartner that there is no future of IT operations that does not include AIOps, period. And as I also mentioned, Gartner seems to do self-predicting prophecies. So, and we are heading into this direction. And if you do a very simple research in the area of AIOps, you will see that basically each and every major player on the market has an AIOps offering. It sounds like if you don't have an AIOps offering, you are not really relevant on the market. So that's the situation. Let's talk about numbers. Let's talk about money. So luckily, this prediction is not coming from Gartner. This is coming from a company called Mordor Intelligence. It's a real company. So, the current state, the current prediction for 2024 for the market size of AIOps is $27 billion. And they did the prediction up to 2029. And if you compare the two numbers, because for 2029, the prediction is $79 billion. Oh, that's a huge difference. It's amazing. So seems like there's a huge potential on the market in this area. And I have the feeling that we are just entering this era. So we need to think about ways how to utilize the power of AIOps, at least to some extent, because there are so many ways we can apply AIOps. And surprisingly, AIOps can not only be utilized in the business field of IT operations. It can be utilized in many other business segments as well, like financials, like healthcare, like logistics, and so on and so forth. The base idea is you take your historical data and you apply the machine learning on top of it, and you use it to analyze your business. However, what kind of operations you need, because if you have operations, then AIOps has a place for you. So let's take a look at some future possibilities. The AI will become smarter and smarter. We know about it. It's continuously developing, so we can expect better and better results from our AI systems. Real-time actions, I think currently it's like in an experimental state, but we can expect this to happen in the future when our system will not only rely on historical data, but it can also react to real-time happenings. The integration with the IT service management system, this is my favorite part, because there are so many possibilities here, especially if you are working in an environment where you have ITIL processes. You can automate the document creation. You can automate the creation of change guides. And then you can decide how much power are you willing to give your AI to perform at least a basic level of remediations. And this in itself can save you a tremendous amount of time. And we already seen experimental projects, very promising in this area. And I truly believe in this side that there is a lot to improve here. The auto-fixing, I think, already mentioned, because there's huge potential in this as well. Although we know about the self-healing possibilities, which already many of the cloud providers are providing. But if we apply the power of AI, we can have better results. The DevOps integration. In DevOps, we have the ops part. And if we apply AIOps on the ops part of the DevOps, we can enhance the ops part. The same goes for the dev part, but it's a different story. So AI can be applied to both parts, and this thing will spin faster and faster. And last but not least, the business-centric AIOps, I think also mentioned. You take data from your business. You take data from your IT operations, and then you can point out interesting things which you probably never thought of. What is going on the business side, and how it affects your AI, or what happened in the business which affected your IT operations. So there is a huge potential in this. And as we are getting closer to the end of this presentation, I still hear the voice of Dr. Bernard Merrick from basically my favorite science fiction movie, which was The Island. And it was like, the possibilities are endless here. And with this, I think we reached the end of this presentation. We still have the question, are we talking about a rubber ducky, or are we talking about a silver bullet? By now, I hope you have your answer. Thank you very much for your attention.
We have time for a question or two. So if anybody wants to ask something. So let me start then. Did you prompt all your nice graphics yourself?
Yes.
Wow,
and most of I think it was obvious that most of the text and the graphics was generated by AI. But there was somebody needed to put it together to create a story. So I think this is also an example how you can use AI as a tool.
That was very impressive. Yeah, thank you. Any questions right now? Otherwise, I'd say I give back a few minutes for you, and then we continue. I'll head back to you, Zoltan.
Okay, microphone is working. So we will continue. Next up, we will hear about some security-related topics, because all these workflows should really reside on secure containers. So here, regarding Kata Containers, we will hear Anastasios Nassos from Nubificus. Yeah, floor is yours.
Thanks very much. Let me just set up. Okay, I think everything is working. So thanks very much for inviting me. I'm Anastasios Nanos. I'm going to talk to you about the Kata Containers project. So we're going to go through a brief introduction of what the project is. We're going to do an installation walkthrough. We're going to see the various runtimes available. So we've got Go and Rust runtimes on Kata. And we're going to see some example use cases that we internally are using, essentially. A brief introduction about myself. So I'm a systems researcher. I have spent some time in academia. I have spent some time in doing some work for a deep tech startup, a bit of consulting. My primary focus is low-level system software, so it's a technical presentation. I'm working on hypervisors, on hardware acceleration, in general, minimizing the overhead of the operating system when we run applications. My involvement with Kata started in 2019, I think, when we tried to use a hypervisor from Amazon, from AWS, to sandbox a workload in an orchestration environment. So the only way to do that was using this project. We continue to be involved in the Kata Containers community to maintain AWS Firecracker for the Go runtime. As a team, we ported the AWS Firecracker support for the Rust runtime, and I joined the architecture committee of Kata to work on various interesting stuff like the ARM CI, further enhancing Firecracker support, and so on. So the Kata Containers project essentially is an open source project designed to provide the benefits of containers and the security, the isolation properties of VMs. So the key points for Kata is that it combines the speed of containers with the security of VMs. It's ideal for multi-tenant environments, and it's compatible with high-level runtimes and orchestrators. These are figures on the left side. You can see the traditional containers. So we've got the hardware platform, we've got the host Linux kernel, and we've got a process on the left running in a container. So we've got the container A and the container B, another process on the right. So these two processes are isolated using the namespaces functionality of the Linux kernel, which is okay. But there are a lot of CVEs, a lot of security advisories that say that a malicious process A can get data from process B, can get, I don't know, storage, can create interference with the other process or with the host system. So what the Kata Containers project is about is that instead of keeping this loose isolation through namespaces, through the host Linux kernel, they spawn a VM and they spawn the container inside this VM. So on the right-hand side, you can see that the container A is spawned using the same binary, let's say. It's the same application, but instead of being in a container on the host Linux kernel, it's in a container on the guest kernel. So we've got a VM sandbox, essentially, and we've got these two containers running on a different VM. So what we get from that is that we have true hardware-assisted isolation between process A and process B, between container A and B. So we have enhanced isolation, and this is through hardware-assisted a mechanism, let's say. We've got a lightweight architecture because we're not using the generic hypervisors like VMware or like these huge VMMs, these huge hypervisors that have to emulate any kind of device or stuff like that. It's just the hypervisor functionality that you need to spawn an application, a container, stuff like that. And of course, due to these two factors, the security and the performance, we've got use cases like secure multi-tenancy, so we can finally have a Kubernetes installation, let's say, with multiple tenants, so we're not afraid that one container can get the whole infrastructure if there is a security issue. It's ideal for edge computing because it's lightweight, so we're not using essentially full-blown VMs. We're using lightweight hypervisors. And of course, this helps with compliance because you can have the ISO stuff that you need at the edge and in the cloud. The users of Kata Containers are, some of the users are shown in this slide. So we've got Red Hat OpenShift Sandbox Containers is based on Kata Containers. We've got Microsoft Azure. So in the managed service, there's a sandboxing option, and I'm pretty sure that there's a preview for the confidential containers project, which essentially is that you don't trust the cloud provider, the opposite of the initial idea of Kata. Of course, Alibaba Cloud and Huawei Cloud, and many more, I'm sure. These are links. I'm pretty sure we're going to share the slides, so you can click on them. So let's have a closer look at how Kata integrate with the higher level runtimes. So let's assume we have an orchestrator like Kubernetes, and let's say we've got a container D runtime on top of that. In order to spawn a container, so in the, let me check which is the container command and exec stuff up there, we get a request from the orchestrator, and the Kata Containers runtime gets spawned. So this is the Kata SIM part. And the Kata SIM is responsible to spawn the hypervisor, to create the sandbox, that is, and boot the VM. So we've got the hypervisor and the guest kernel, and this is a virtual machine that is going to spawn this container. When the VM is spawned, the first thing to do, the init process in the VM, is the Kata agent. So this is a small agent that receives requests from the Kata runtime and says, let's spawn a container. It mounts or it gets the root file system, the container image that we need to spawn, and it gets all this information from the Kata runtime. So this is through gRPC, and when all the information is available, the container is spawned. So it's a simple process, and it's what it does essentially is that it boots the container in a sandbox, in a VM sandbox. Pretty simple. What we're going to see next is how to install Kata. So we've got, as a project, we've got two modes. The first mode is using a Kubernetes operator. So we've got the Kata deploy container image. You deploy it on your Kubernetes cluster, and you've got Kata installed. And the second process is through the static release binaries. We've got packages on GitHub. You can get the package, you do some config stuff, and you're ready again. And we're going to show that on on a fresh Ubuntu 22.04, using both the Kubernetes thing and the static release. Let me just switch to the video because holding the microphone, and typing is a bit tricky. So what we're seeing here, a bit small, but what we're seeing here is we bootstrap a K3S Kubernetes installation. So that's pretty standard. We get K3S, we set up the config file. We don't have any pods. We need to create the CNI to get the pods running, the network. We configure some internal CIDR stuff. That's again pretty standard. Now we clone the source code, but we only do that to get the manifests and the versions of some of the components. We're not building from source. Yeah, it takes some time. So we apply the RBACs and we apply the kata deploy operator. So we get, we also apply the runtime classes. So we specify the runtime classes as a Kubernetes option in order to differentiate between which hypervisor, which config option we need to use with Kata. So in order to spawn a container in Kubernetes, we need to say, is it a generic one? Is it a Kata Containers one? Do we use Chemo? Do we use AWS Firecracker? And so on. So this last YAML file is a generic Nginx deployment using 2 replicas and using the runtime class of Kata Chemo. So essentially what's going to happen when we apply this YAML file, we're going to get 2 containers running as part of the Kubernetes orchestrator. And if we inspect the processes in this Linux box, we see that there are 2 Chemo processes with a lot of command line options. But that's you don't have to write these options yourself. This is handled all by the internal tooling of Kata. And the second part, and the second deployment refers to another runtime class within Kata, which is the runtime RS runtime class. So the Rust runtime of the Kata containers. We'll see about that later. And we also get 2 containers. And at the moment, what I want you to take away from this is that we inspect the 2 processes and we get just one single process. We got the hypervisor on top, but now we've got the runtime and the hypervisor combined on one single process. And we'll see about that later on. So that's the installation process for the Kata deploy operator. The installation process for the static release is kind of similar. It's not the same. So we need to get some tooling to parse the correct versions from the Kata code. We get a tool to interact with the runtime, so we get nerdctl. We clone the code again. We install containerd from scratch, as we don't have K3S that bundles everything together. We configure containerd, so we set it up to start at boot. We might as well skip all these. Okay, we get the CNI binaries, so we need that for the networking part of the installation. We get the static binary from GitHub. So this is a recent release, 3.5. And all these files refer to different options for the Linux kernel of the VM, the rootfs of the VM. There are options for GPU pass-through and the confidential container, stuff like that. We also need to set up helper functions for helper scripts for defining the different configuration options. So we've got a single runtime, and with a configuration file, we can say boot with Kata Kemu, boot with Kata Firecracker, etc. And we go on to spawn containers like before. So we use this tool, netctl, which is a tool to interact with container D, with the upper, with the high-level container runtime. So what we do here is that we spawn without sudo this container. So we spawn this container with sudo, and what we get is the reply from the command. So we did a uname -a, give me information about this Linux box, and we got the information that says that refers to the actual VM that is being spawned. So what we see on the right is the Kemu process and the netctl invocations. Now, if we use another variant of Kata, the Dragon Ball variant, the Rust runtime that is, we see that there's a single process both for the runtime and the hypervisor. And what we're doing now is that we edit the configuration file of Kata Kemu to enable the debug, the console of the VM. So what we're going to see, essentially, is on the left side, we're going to see the container console, and on the right side, the VM sandbox that runs this container. So we spawn using a shell. We see that there's a Kemu process. And we use this tool from Kata, the Kata runtime exec, that essentially opens up a debug connection to the VM itself. So what we see on the right is that we are running on a 6.1.62 kernel in the VM, but on the host, we have another Linux kernel. So this is proof that this is a VM sandbox inside the host that we're running. And on the left side, we see that it's a container. So we don't have the same mount points as on the right side. The right side is the VM sandbox. The left side is the container running inside the sandbox. They do share the Linux kernel, so the dmesc output is the same. And we're going on then about mount points. We can just skip mount points. We can just skip that and continue with our presentation. Okay, so we got an idea of how easy it is to install the Kata Containers runtime. So I suspect that the Kubernetes thing was a lot more easier. If you want to develop or if you want to inspect, to dig in the Kata Containers project, the static release or building from source is obviously the way to go. Now, back in, I don't know, 2 years ago, I think, there was this battle about whether going with Rust or keeping the runtime with Go. And essentially, I think that the Rust people have won. So we've got a complete re-implementation of the Kata Containers runtime in Rust, and these two runtimes coexist in the source code, and most probably in the release 4.0, the Rust runtime will be the one to go, to stay, let's say. what happens there? On the left side, we can see how things are done with the Go runtime. On the right-hand side is what changed with the Rust runtime. The key difference is that the upper layer runtimes spawn the Kata scene on the Go case. The Kata scene spawns the VM sandbox, and inside the VM sandbox there's an agent that communicates with the Kata scene. So the hypervisor is external to the Kata scene. So it could be Kemu, could be Cloud Hypervisor, could be Firecracker, anything. On the right-hand side, on the Rust runtime, what happened is that we glued together the runtime and the hypervisor. So using Rust crates and based on the on the Rust VMM hypervisor, people have unified the Kata Containers runtime. So the higher level runtimes now, what they do is that they call the Kata Containers Rust runtime, and the Rust runtime calls the internal hypervisor. So the sandbox is being created by the runtime itself. And we get the same isolation properties as before, only now we get one process per sandbox, not two, not the runtime and the hypervisor. We get one process, which is the runtime and the hypervisor in one. So the Rust runtime, what it did is that it unifies the runtime and the hypervisor. With this, there's a reduction in the resource consumption and the management complexity. Again, the integration of the hypervisor and the runtime makes sure that there's only one host component for each pod, which means that there's less attack surface, so it's more secure. And of course, it aligns with the trend in the Linux community that everyone says, let's rewrite everything in Rust. The current support for the Rust runtime is shown in this figure. So we've got Kemu, a Cloud Hypervisor, and Firecracker almost supported. The Dragon Ball hypervisor is only available, of course, in the Rust runtime because it's built natively for this. So we didn't backport the Dragon Ball hypervisor to the Go runtime. We could, but there's no obvious reason to do that. And there is, in terms of feature support regarding the Rust runtime, we've got a GitHub issue that we track all the features available in the Go runtime and the Rust runtime. At the moment, 66 individual features of the Go runtime are available in this matrix, and only 15 are not yet available in the Rust runtime. So it's work in progress. We've got PRs being merged as we speak to support these features, and release 4.0 will come with the default runtime as the Rust runtime. We will not ditch the Go runtime because it's widely used and tested, but the default runtime will be new features will come only in the Rust runtime. Now, we're going to see now use cases that our team is doing, how we use this project, the Kata containers, how we use the isolation properties of this container runtime to integrate it with two things, essentially: sandboxing serverless functions and exposing hardware acceleration features from the hardware to workloads without the workloads having direct access to the hardware devices. the first thing is we're using Kata Containers as a runtime class to spawn Knative functions, which is useful because it extends Knative's threat model. That means that we can, using Kata, we are able to have a multi-tenant Knative cluster, whereas at the moment we only have, if we don't use Kata, we have to have a dedicated Knative cluster per customer, per tenant. And the second thing is more researchy. So we internally, as a team, we've built a framework called VXL, which exposes, using API remoting, hardware acceleration functionality from devices like GPUs or FPGAs to workloads running on VMs. So we integrated this to Kata. We have a downstream branch, and we're able to give hardware acceleration functionality to workloads, to containers running on Kata without PCI pass-through, without giving the whole device to the sandbox, to the container. So in the Knative use case, this is a figure of the Knative architecture. So we read it from the right to the left. So there are clients that request an endpoint, a function from the ingress controller on a Kubernetes setup. The ingress controller talks to the activator talks to the autoscaler, whatever. But the autoscaler talks to the Kubernetes API, and the Kubernetes API says, do I have a container spawned for this function? I don't. I will spawn a pod. So there's a pod being spawned. There's in a Kubernetes node in this box, and we've got a container having we've got two containers, one pod, the Q proxy container, and the user code. That means that the user code runs as a container on a Kubernetes cluster. If we've got a malicious user that submits code that would like to inspect the rest of the containers, or there's I don't know, a zero-day CVE, there's a privilege escalation issue, or even interference between containers, this is not what cloud providers want. So what they say at the moment, cloud providers, is that you get your own dedicated cluster and you can run your own stuff there. They don't offer Knative as a service, let's say, because it's not safe to run multi-tenant stuff like that. What we thought that would be useful is that to try to run the user code in a sandbox, in a VM sandbox. So this is super easy with Kata. So instead of using the generic runtime class for the Knative function pod, we use the Kata Kemu runtime class or the Kata Firecracker runtime class. And this thing provides the isolation that we want from the user code running on the infrastructure, and it's for the user there is no difference. It's a container that has its code and it's spawned as a function. Let me just forgot the slide. So what the next demo is about is we have a K3s cluster. We have installed Kata like before. We have installed the Knative serverless framework. We have set up ingress and DNS and stuff like that, which we're not going to show you that. And we deploy a specific function, which is an HTTP service that replies with its headers. And we have set up DNS for all the runtime classes that we support, and we just point to the different runtime class. Let me just find the I hope you can see. So on the terminal, we see that there's a Kubernetes cluster. We see that Knative is installed, and we query for the Knative services. There are no services installed, so there are no endpoints. Everything is empty in the specific namespace. To define a service in Knative, all we need to do is apply this YAML file, which is a service. We get the name of the service, the namespace of the service, and we also get this domain mapping. This is DNS related thing. What is important to note here is that we deploy one container image, the same container image for everything. At the moment, we don't have a runtime class. We have the generic runtime class, so it's a non-isolated container. We apply this YAML file, so we get the function deployed. We can see that there are no pods now running. We issue the request, so we are the user in the previous figure, and we can see that the pod is being spawned upon the endpoint connection. It serves an HTML thing with some headers, and that's fine. This is a generic a container. Now, if we have set up YAML files for the rest of the services, for the rest of the runtime classes, the container image remains the same. So we have no change to the user code. The user just supplies a container image with their code. We apply we create all the services. We can see that the services are created, if we type it correctly. So we've got all these services available, and we start querying, we start invoking these functions. And hello FC spawns a firecracker container, a Kata container. Hello RS, I'm not sure what's the next one. Hello Kemu spawns a Kemu container. Hello CLH, the cloud hypervisor container. And all these, the purpose of doing the whole runtime class, the whole spectrum of the runtime classes, is to show that it is as easy as one runtime class to spawn to configure the rest ones, and that changing the threat model of Knative by introducing these isolation characteristics is as easy as installing Kata and specifying the runtime class essentially in the YAML file. When inspecting the processes here, it's just to show that there is the specific process is the one spawned by the invocation of this function. Let me go back to the presentation. To move on to the next use case. So regarding the hardware acceleration, what we've built, the VXL framework, is essentially an API remoting framework. So we've got a user-level application that consumes the VXL API. The VXL API has specific operations. So we've got image inference, like image classification, image segmentation, stuff like that. We've got specific TF and Torch API operations. So we support the JIT load forward one. We support the load session from running model from the TensorFlow, and blah, blah, blah. These are API operations, dummy API operations. These operations get matched through a dispatcher to the relevant plugin. So we've got this notion of plugins in VXL. essentially what plugins are the glue code that connects the API operation to the underlying hardware-specific implementation. Let me give you an example. So we've got an application that wants to run image classification. We consume the VXL API, so we call VXL image classify with the arguments. The dispatcher looks for available plugins. Let's assume we've got the JSON inference plugin. The JSON inference plugin, essentially what it does is that it implements this API operation using an external library that already exists. So we got the JSON inference thing from NVIDIA, from a GitHub repo called DustyNV, which is the person that implemented that. We built it, and we've got a shared library underneath our own plugin, the JSON inference plugin. And what we do is that we connect the API operation of image classify to this plugin. The same stands for the TensorFlow and for the Torch approaches. So, sorry about that. The specific example now that we're going to show is the following. We've got, we implemented a simple Torch example. We've got a Torch operation that uses a specific model. It classifies text, hate speech classification. It's a textbook thing we found online. And there are two implementations, the CPU implementation and the GPU implementation. This is the generic execution. So we've got, on the left figure, we've got a simple application built with CPU, with the CPU Torch libraries. And on the right side, we've got the same application built with the GPU libraries. So we're going to run that and see the throughput of the operation running on 1,000 tweets from this large data set. It's a Hugging Face data set. Actually, these are links, so you can find all the information about the demos that we show in this link. The next thing to do is to run the same application, the example, as a container inside a Kata container. So the only thing that we have is CPU. We don't have GPU pass-through because there are implications when you pass through, when you assign, when you pass through the whole device to an untrusted VM. So we don't do that. So the only thing that's left for Torch to run is CPU. So we get the throughput there, and the next thing to do is using the VXL integration that we did on Kata. So what happens here is that we have a virtual plugin, a VSOC plugin. So instead of gluing the Torch API operation to the Torch GPU plugin that we have available, we have this remote plugin, the VSOC plugin, that forwards requests through the guest kernel, through the transport mechanism, through VSOC essentially, to an entity running on the host that has direct access to the hardware. So essentially, we are giving the BERT example that runs in a container in an isolated VM, we're giving it the opportunity to run on the GPU. Let me go back to the... Again, the letters might be a bit small. What's going on here is that we open 3 terminals. We get the list of the tweets, the first 10 tweets, let's say. This is hate speech, so please don't read them aloud. And we're running the CPU version of the text classification using Torch. And we can see that it's running on a single core. We have an average duration of about 100 milliseconds. And we can see the number of each tweet being classified on the left, and on the right, whether it's offensive language, hate speech, or whether it is neutral. And we can go on and on, wait until the 1,000 tweet. Let me just move that. So we see that the average time it took for each tweet was 95 milliseconds. On the right side, we inspect the GPU utilization. There is no GPU utilization. On the H-stop window, we see the CPU utilization. We limited the execution on one single core to compare apples to apples, and we see that it's 100%. Now, I think we might be missing the local GPU execution. Yeah, we are. Apologies for that. So I can show it later. So this is. So what happens here is that we spawn a container using the Kata Firecracker runtime class. And what we do is that we spawn the same command, classifier with the specific model, with the specific parameters for the vocabulary, and a parameter to say run locally, run over CPU. So this is the exact same binary with the exact same parameters running on a Kata VM. Again, we see the torch behavior. The initial large numbers is torch specific. We see that the rate of the classification is quite low. I can move that forward. We inspect what's going on the right side. We inspect what's going on with the container, with the Kata container. So it's sandboxed. We see the Firecracker process running. Everything as expected. And it finishes, and we've got an average of 98 milliseconds per tweet. And we do the same, only now we're using our own runtime class, which is a downstream version of the Kata Containers runtime with VXL. We run the same command, only we use 0 instead of 1 to signal the VXL thing. And we can see on the right-hand side, we can see that there's utilization for the GPU. And we can see that the rate of the classification is a lot better, which is expected because it runs on the GPU. And on the lower side of the terminals, we can see both the Firecracker process and the VXL agent, which essentially is the tool that issues the requests to the accelerator. And we can see that the average time to classify a tweet is 18 milliseconds instead of 198 that was before. Let me go back to the presentation. I would also like to mention that parts of this work have been funded by EU-funded projects. And to summarize, we saw an overview of the Kata Containers project. We saw how to install it using both modes, the Kata deploy operator and the static release. We talked about the Go and the Rust runtimes. And we saw a couple of use cases that internally were using Kata Containers. You are welcome to try Kata Containers out. Everything is open source and available on GitHub on the webpage. I'm really eager to release V4.0. with the default runtime class being the Rust one, with the default runtime being the Rust one. We have enhanced hypervisor support for the Rust runtime. We're working towards getting everything in place. And there will be also support for the confidential containers project, which is a fork, essentially, of Kata to support the opposite use case, to run something trusted in an untrusted host. That's it from my side. Thanks very much. Please join the mailing list, join the Slack channel, give us a shout on GitHub. We'll be happy to hear your use case or to help you set up Kata in your environments. Thanks very much.
So maybe one quick question. Over there, yeah.
Thank you. Actually, it's not a question, just a note. So when I hear multi-tenancy in Kubernetes, that's nice, this separation, but people don't talk about the network separation, which I guess does not exist, so I don't expect it from you. I mean, between the tenants, I mean. So like in OpenStack, for example. This is simply not addressed yet.
The network separation...
Let's imagine you have two tenants, like in an OpenStack-ish way, and you want that kind of network separation in Kubernetes. So process separation addressed here, fine. The network is a different story, and you just use standard CNIs, as I saw.
Yes, but there are also directly attached network interface support for in the Rust runtime. So you've got that as well. And you can also run your network functions on Kata containers. So I suspect you can achieve what you say.
No, I don't think so, but I will be happy if there will be a solution for it. It's not addressed by Kubernetes itself, because most Kubernetes clusters are running on top of a cloud, so you get this kind of separation from the underlying cloud, usually. That's a different story. Just, again, it's not a question, just a note.
Okay. Anyone else? So are there already plans for a release of 4.0?
So yes, there are specific bullets that we need to address in order to get to 4.0. So the first thing is to get the Go stuff running on the Rust runtime, which is, I think we have 10 or 15, as I mentioned, items that we need to support. And we have a different issue to track these as well, the specific ones. And there are also some optimizations on the file descriptor side, so we get faster I/O in the Rust runtime. Yeah, I think it mostly covers that. That mostly covers it.
Okay, I see you are a Rust fan.
No, I'm not. I'm not,
okay.
but it's a good thing that Rust comes along, and it comes with the efforts of many good people from the community that have pushed, and it's really nice to see that.
Okay, then let's keep fingers crossed to see this release pretty soon. We have another break. Is that correct? Of I think 15 minutes is. Correct, Zoltan?
Yeah, exactly, 15 minutes coffee break, and then afterwards we will continue with the panel discussion, yeah?
Exactly.
So we are waiting you back.
See you back then.
So welcome back, everybody, for our panel discussion with the title, How Does AI Affect Our Work in Cloud Operations and Development? And here in the panel, I'm honored to welcome four gentlemen. Thierry Carrez, who is the General Manager of OpenInfra Foundation. Arpad Jorgic, our Innovation Director in DTITS. Thomas Weber, Chief Product Owner from Huawei Technologies. And Adam Barkanyi, you have already met him, a Product Owner in OTC. So, after this short introduction, let's start with a warm-up question. Exactly when and where did you consciously met an AI solution, and what were your impressions about that? So let's start with Arpi. Arpa, the floor is yours.
That's a good one, Zoltán, I have to admit. Considering, you know, the way how we specify AI with specification, I think it's a very broad one, and the fact that you were asking something personal, I think I would say early computer games, and to be more precise, text-based adventure games. The date is the early 90s. And if you are not familiar with the genre, text-based adventure games invented, you know, around the 70s and 80s, when games couldn't really have proper graphics or user interfaces. So everything happened basically text-based. So the program described you what's happening around you, and you had to type in words and sentences in order to do something with the game. Push this there, pull it here, pick that up, move here, move there. And interestingly, those early games, you know, like Zorp or The Hobbit, they were able to analyze, processing, recognize very complex sentences, not just simple words. So if you think about how you interact now with LLMs these days, actually it's not very different. And we talk about, again, you know, the 80s. So it was super immersive and immediately gave you the feeling that you are doing something with the software. You are having a conversation with the software, which was super exciting to me in those days. And of course, I could give you an additional example from the gaming, where if you think about, you know, real-time strategies, a racing game, or even, you know, when you play with Halo or some other third-person shooters, the allies are fighting next to you in some cases, or try to react on your behavior on the fly immediately. Are these real AIs? No, of course not. Especially if you think about, you know, these text-based adventure games. Everything is encapsulated in a sandbox environment. Everything is simplified. So those solutions are not real AIs, but still the feeling was to me at the time, and I was a kid, that, oh my God, I'm really doing something with that software. And that's also showing the aspect of artificial intelligence, but that applies to many other things, you know, which is labeled innovation these days. Then the human factor, the emotion, is very important. And I think, you know, if you look at, you know, the big boom and the big hype around all these LLMs and ChatGPTs, we can see again that human factor in there. But again, back to your questions, those were my first experiences with AI.
Years, yeah. I think maybe these were based on these if and else cycles that
of course,
Adam was talking about, yeah. Yeah.
But it was really, you know, the whole thing was really homebrew in some cases, especially in the 70s, but worked pretty well.
Yeah, yeah. Yeah, thank you, Arpi. Let's continue with Thierry. What were your first?
I would say consciously interacting, like willingly contacting an AI, or like interacting with an AI as the first reason to really do the action. I would say when ChatGPT was first launched as a private beta for only by invitation, I got on the first thing to try interacting with an AI in a conscious manner. But I would say, yeah, the gaming from maybe the chess computers that, you know, beat you every time when you try to play, and that was very frustrating. That's like a proto form of AI, because it would like compute all the possible scenarios and then rate if the position they get in is better than the position they were in before. So you could argue that it's also an early form of artificial intelligence, basically crunching data for getting some kind of a scenario and grade it. That would be my first unconscious interaction with an AI, but otherwise yes, the LLM experience is probably the most telling, because it feels like it's behaving more like a human. So there is the artificial part is pretty clear in there.
Thank you. Yeah, cautious. This is a very good word. I think the first time interacting with AI in a conscious way is like 20 years ago. I was having an internship at the local University of Applied Science of North Rhine-Westphalia in Germany. And at that time, the professor I was talking at that time, he was basically handing out a book to me as a gift that he wrote basically about principal science and mathematics of fuzzy logic. Now, fuzzy logic, at that time, they were doing research at this institute. For example, the students were trying to solve the traveling salesman problem using fuzzy logic. Well, they didn't succeed, now we know. But of course, fuzzy logic is still around as one domain of artificial intelligence. At that time, we were doing this route mapping and trying to find the shortest path and everything in a more, yeah, let's say, rudimentary UI. And of course, all the coding around that. I mean, nowadays it's still around, right? So fuzzy logic is still being used in very many fundamental cases. Maybe not in ChatGPT, but for segmentation cases or cases for pattern recognition. This is basically where fuzzy logic showed to be very useful. So that was my first experience.
Sure, sure. And I think that was lucky times that even during these AI winters, there were still some groups working on the basic research.
It was all just preparation.
Yeah. Under the hood. Yeah. So Adam.
Thank you very much. I think being lost in this round makes my task very easy, because all I can do is summarize everything what I heard, because I can relate to ARPAD, especially to this role-playing games, the text-based games. Those were amazing. I also remember being a kid, I wanted to believe that I am interacting with a real artificial intelligence. Of course, it was not true, but again, as Thomas mentioned, conscious. When was the first time I would say I had an interaction consciously with an AI? And my first interaction, I would say, was the same as with Thierry. When ChatGPT made the first model public, then we knew that is something special. That is a highly intelligent something that we can expect. But before that, I would say customer service chatbots, like 5 years ago. I remember living in the UK, and when I had some problems, I was really amazed by the advanced technology it was used by that time. Of course, it was not giving you the quality of answers that you can get right now from currently from the ChatGPTs, but still, I could manage to solve my problems, and I consider it as a successfully working AI. So that's it.
Yeah, thank you. So the next question would be about solutions and whether they really met your expectations. So as a professional, what kind of AI solutions have you already met? Have they already met your expectations? And were there any changes in the last 5 years regarding their development? So Thomas, maybe you can start answering.
Yeah, of course. Yeah, maybe it can be like two extreme examples. I would say in a positive manner for me, for example, we have something that is really impacting human beings on this planet or life in general is like things like, for example, the weather, right? So most of you may know the magazine Nature. Basically, all the scientists, right? They have one target: make publications and get to the nice magazines. This is nothing different in Huawei, right? So everybody wants to make the nice publications and get to these important magazines and get the prestige. And we just recently published also about our Pangu weather forecasting. So this is something that really makes a very good example where very accurate AI-trained weather forecasting can basically improve the precision of extreme weather events like storms in general, typhoons, for example, and also for the baseline weather forecasting extremely improve just the time it takes, right? Nowadays, European weather forecasting institutes like the ECMWF, it's the European Weather Forecasting Institute for Mid-Term Weather Forecasting. So they do the prediction of all your weather for like the next 5 to 15 days, something like this. And they used our model, they did the benchmarking, and nowadays they use numerical models, right? So you need this classical HPC 5000 node cluster to execute, and basically they can then run a job for like 10, 12 hours, right? Using our Pangu model, they were able to do it like in seconds with higher precision. Of course, this also always depends like on these critical events. You want to be very certain that you can always achieve the same level of quality. So it's a lengthy process to get into this kind of scenarios, right? But this is something where I see the improvement over the last year is extraordinary. That would be the positive side. The downside for me is like a lot of things that are around, yeah, all this digital human stuff, right? The approaches where you create an avatar for yourself, either on an more, yeah, let's say artificial way, looking more like a comic or something, or even in a more realistic way. I don't see that is like a successful scenario at the moment in Europe. Maybe this is something that takes more time in an augmented reality way or in Web3 or other scenarios. But for me, this is a negative example that does not show its actual value, right? It's more like a nice, fancy thing to show, but in reality, it doesn't hold that much value at the moment for me.
Yeah, but predicting natural disasters and in a timely manner, yeah, it really counts, even the seconds. Yeah. Thank you. Adam? Your impression?
I can also bring positive and negatives. Unfortunately, I didn't have too much experience during my professional life with AI systems. I can bring up only one example. Again, it was a chatbot in a customer service field where we were developing this. It was a very basic one. The reason I brought this up because I wanted to show something where the answer has changed over the past 5 years, and compared to what we had like 10 years ago to what development this area reached. So that is amazing. This is the positive side. On the other side, I can bring up like a personal experience because I was experiencing myself on the financial in the financial sector with trading bots, which had the promise of using AI and using it in real life trading. Of course, I don't think that has a future, or at least I didn't have good experiences with that. So that's what I can bring up as a negative experience.
Yeah, most probably this is also a stamp like on the pen. Yeah, it's an AI-powered.
Exactly, exactly. And you never know, especially when it's closed source and it's proprietary. Then you don't have the chance to look inside it how it works. So you just believe what is sold to you. So.
Yeah. Thank you, Adam. So we continue with Arpi.
I think I can also share a few positive and not so positive things. Starting with the positive, coming from the role itself, I'm having a pretty good overview about what's happening around AI within Telekom and T-Systems International, and also with some of our customers. And based on that, I think we are getting in a more productive mode. So if I look at AI from the perspective of typical hype cycles, I think we have at least 3 or 4 times more, productive use cases than we had a few years ago. So if I'm looking back during the last few years, we learned a lot about these techniques and technologies. Sometimes we were supported a lot by our partners, looking at Thomas, for example, on that. And that was very interesting. And a lot of internal discussions started within Telekom and T-Systems about platforms, what can we do these things, usually about big things. And I think our top management didn't fully believe, about all these things, what we could achieve with AI. But then the team started to come up with their own use cases, the tangible ones. And for example, we have an innovation room in this building where we showcase the current portfolio of T-Systems and Telekom. A lot of these new portfolio items are AI related now. but we are also showcasing a lot about the bottom-up projects we have, and also some solutions what we provide directly to our customers. And the best ones are always, actually the ones I like the most, are the ones which are the bottom-up. And we have a lot of interesting internal projects like about, and I know, plant disease diagnosis. We can scan broken QR codes, or we can do video translation for hundreds of languages. And these are very interesting ones. And some of them, in the meantime, became actually business-related use cases. So, for example, we also have a sales assistance solution. Based on prompt information, we can provide battle cards to our salespeople when they approach customers. And these are super great. And we use a lot of technologies, a lot of platforms, from Open Telecom Cloud to Azure, Google, AWS. We do everything on all platforms, but that's okay. We are a system integrator, ST Systems International, and even within Telekom, we use 2 or 3 platforms constantly. Where we are not there, I think, as Deutsche Telekom or ST Systems International, we started a lot of thinking about big programs, top to bottom ones, where top management started to believe in this technology. And we also started to define a better governance about these tools, because that's also came up immediately when we started to use things. So if you just remember Copilot, when it first appeared, a lot of colleagues started to use it immediately using their private accounts. And we had to react very, very fast, actually, as the Systems International, that maybe we should include it somehow in an official way, because we felt already that we want to enable our colleagues to use Copilot, but we wanted to use their company account for that. This is just an example. At the same time, I have the feeling that top management, and this is what I see when I'm looking at our customers as well, they now expect, this type of one big button type of solution, that I just need to hit that button and everything will be solved with AI, which is also not the case. The customers are now experiencing also a lot of limitations coming up. You need to have somehow structured data because you always need to do garbage in and garbage out with that, and need to consider a lot of things. But again, the good thing is that something have started definitely. And we are not just playing in sandboxes anymore, that we have tangible solutions, and some of these things are already running in our customers' productive environment. So I'm very positive, and I think that's normal. This is how we learn these technologies, and this is how we can also educate ourselves as a company, step by step. And with that, we will eat the whole elephant, of course, but it will take, if you're asking me, at least 1 or 2 additional years when we will really reach that industrialized stage where we are not there yet at the moment.
As usually the case with all the hyped technologies.
Yeah. Mm-hmm. That's okay.
Mm-hmm. Yeah. Mm-hmm. Yeah, thank you. Thierry, do you have similar experiences?
Yes, I think the 2 areas where we've seen a lot of quality is classification, which we discussed earlier, like recognizing patterns on images, and all the medical applications where you can help doctors to make a good diagnosis in looking into radiographies or other medical records. And the extreme case is the weather forecast, like you said, because they just look at the current state of the weather, the current recent evolution, try to predict exactly what's the most likely scenario out there. And it's interesting that you mentioned the ECMWF, because they're actually running those models on OpenStack clouds. So that brings, you can tell how much of those new workloads require infrastructure to run, and how much we have a role to play as an open source player to provide a solution to do that with open source solutions. So yeah, classification is one area where we've seen a lot of progress lately, especially since the amount of power in the hardware that is now available to run those things is much better than it used to be. So you can do pattern recognition in real time now, like scary examples from some corners of the world where we're seeing faces being identified in the street really fast. Or so classification is one. The other obvious scenario that we've seen a lot of recently is the generative AI, which like tries to predict the next element in a text, or tries to predict the next elements around an image, or the next element around a video. So all that, like almost auto-completion on steroids, like I like to call it, is super interesting because there's a bunch of use cases where it's really good, like automatic translation, summaries of texts, and that's where I think we've seen new solutions and really good quality. But at the same time, the problem, and I guess that's topic of the next question, but we're seeing problems when people start to think that it's doing something that's not designed for. Like, for example, bringing the truth, like Google responding to, like you said in your presentation, like Google responding to queries which look for the truth with some statement that's derived from, well, how about use glue to stick your cheese to your pizza, or how about you eat some rocks and see what happens. And because people are asking those chat models for the truth, and they are not designed to bring the truth. They're designed to bring something that looks like an answer and based on training data. And it's going to be super difficult to turn that use case, which is super interesting, generative AI, into something that will give you the truth or give you something that you can actually act on. And I think that's the challenge. It's really good at some things, but people want it to be good at everything. And they apply this model in their mind to, well, it looks like a smart person when I talk to it. It must be smart enough to give me the truth. Well, it's actually not as good as like the Google search was a few years ago. And so that's a bit where I think people need to understand enough of those technologies to actually see where they are really good and where they are really bad, and not transfer from one to the other.
Yeah, and this is exactly the next question regarding this quality and how to deal with problems. Adam also touched in his presentation, and Thierry, you also mentioned. So, yeah, what can we do with all these hallucinations that we can experience when we are asking generative AI solutions? So, Adam, do you have any solution?
So I think it's obvious that the problem is on the receiving side. So the problem is with the human who tries to give things to the AI which are not there. So the human thinks that if the human doesn't receive the truth, then the AI is lying. No, the AI is not lying. AI is giving you the answer which it always will. But how can we deal with this in an organizational level? I would say, in short, common sense. We need someone to justify the answer. But what if we look it from the other side? This year in February, in Hong Kong, it happened in a financial institution that an employee was invited to a group chat. And basically the board members were there, the CFO and all the other board members. And this employee was instructed to transfer $25 million to a certain bank account. Once the call was over, the employee realized that he was the only human in the call. Everybody else was a deep fake of those people who looked exactly like the board members, like the CFO and all the others. What can you do in this case? If you are this employee, what is the level of trust you can give? So I think this is still an open question.
Yeah, it's going now well beyond this hallucination, yeah? But right point, yeah?
Yeah, I can, am I audible? Yeah. I can follow Adam's description. so I have nothing to add to that. So this level of trust topic is definitely something to be clarified. But you know, since my technical background, I will look at this from a more technical perspective, specifically about the hallucinations. There are technical solutions to that. So usually we invoke technologies, for example, like RAG. It's like a retrieval augmented generation, where you basically take your existing language model, for example, create a vector database based on your own data. For example, I don't know, I think everybody of you is creating documentation, for example, and usually that's internal documentation. So if you want to have an LLM answering your architect the question how to do this, how to do that, if you go to OpenAI or whatever LLM that is publicly available, most likely they will not know the answer. And if they know an answer that is close to what you want to know, then the answer will not contain your specifics of your system, because in best case they are secret to your company, right? So this is how you can use, for example, large language models to create an environment that first has less hallucinations, and second is secure to your dedicated secret information. So you have basically two benefits. Why is it helping you with the hallucinations? Usually AI systems, they are not making up something because they are in the mood to do so, right? Because they don't have a mood. Be clear about that, hopefully. And basically, they make up things because they are good at it. And if they don't have information, they will just combine something that for you makes no sense, but for them, in the weighting system, yeah, it's close to each other. So if I have nothing better, then I use that. That's how it works.
Fill the gap, yeah?
Exactly, fill the gap somehow.
Yeah, yeah. Mm-hmm.
And just to continue, this is what we already do, exactly what you described. The solution I just mentioned, the sales assistant tool we have, it's a very simple thing actually, based on prompt information, for example, about a specific industry or customer problem. It is looking at our own data, which is classified, you know, checked internally, which is our portfolio. And based on that, it gives a very specific answer which applies to that customer. But we wanted to avoid hallucination at all, because we can't afford that. You know, our salespeople can just come up with, you know, something, you know, suggested by an LLM model. So we use exactly the same technique as you said, basically using our own data, basically, still using, in this case, ChatGPT. And based on that, we put together a specific, you know, slide deck and different parts of our portfolio, which applies to the specific program of this customer in that specific industry. And that is saving a lot of time on our end. Of course, we do other things as well, because there are other problems with AI that comes from governance, GDPR, and we are a European company. Of course, Telekom is global, but we still feel ourselves as a European company, so we need to do a lot of things around regulations, which is okay for us. And another typical area what we try to control somehow, or at least, you know, establish some governance around that, is the inputs what we give to those LLMs. So how to secure your prompting activities. And in some cases, we use web interfaces, and through that web interface, because before the actual prompt reaches, you know, the LLM, you can define your own policies and rules. And actually, we also use a system prompt. So this is the area when you can define the behavior of your model, and that also helps a lot. So for example, if you want to make an LLM available to your whole staff, you can also teach the model itself how it should behave and what type of answers it should be answered. So I think that's also a good thing and a good way. And all customers are highly interested in these things, because they already would like to onboard themselves to these new technologies. But especially in Europe, they, you know, immediately have the feeling that, okay, but where is my control then?
Yeah, sure. And I even saw a solution where the source was also somehow indicated that, okay, this is the answer, but this provided as a basis for that answer. So maybe that with that one, if it is only from a public chat, you can immediately see, okay, this might not be.
And this is not only
truth.
feeling, right?
Yeah.
So European legislation with AI Act will exactly also require such scenarios, specifically for risky workloads, right?
Yeah.
So they have this categorization. So this will be fun for all of us.
Yeah. Thierry, would you like to add something?
I think the trick to avoid issues is to write the AI tool, to use the AI tools at the right level. Like you should use them for what they're good at and not use them for what they're bad at. And so I will give like 2 examples. Like, well, first, you should not assume that they know the truth. It's not good for reference data. It's good at making sense of a vast mass of data and digesting and producing some answer, but it's not that good at finding what's true and what's false. And the 2 examples would be, so if you take, for example, writing code, because we are talking about development here, so you can use a copilot type things to help you write the code. It's going to produce, at the first try, produce code that might not work. But if you combine it with functions where they would run the code and then interpret the error message and then refine, over a few runs, it will actually produce code that's working, because you enrich it with running the code and the error messages that, or the bad output that you get out of the first run, to improve the second run and third run. So that's the type of combination between, I would say, traditional trial and error and AI is actually producing good results. Another example is on the search engine front. So the bad way of doing it is the Google way, where they just like try to synthesize an answer using a pure LLM that's not good at finding the answer, but just good at producing something that looks like an answer. But if you look at Perplexity.ai, for example, which is another search engine, what they're doing is that they're using AI to combine answers that they find in the usual way by finding sources that are reputable on the internet, and they give you a synthesis of what they found with pointers to the reference information, which makes it super useful, because then if you're not like satisfied or you have some doubts on some of the answers, you can click on the links that they use to generate the final answer, so you have direct access to the underlying data. So it's a good, I think the trick is to not place blind trust on those tools and then use the AI generative or AI classification parts for what they're really good at, and then combine it with more traditional approaches, like finding reputable sources or training on reputable sources or running the code and see what's happening, which we're doing anyway.
Yeah, and in many cases, common sense, right? Can also help a lot. Yeah, so now I see an indication that we are a little bit running out of time. So, and we also wanted to give an opportunity for the audience to place some questions. We didn't really touch the point of how we are expecting that AI will transfer the future for us, but maybe out of the questions we will have some similar approaches. So.
Maybe you couldn't continue first with your question.
Yeah, sure. So this may be the first question. Maybe it will also generate some additional from the audience. So how do you see that AI will transfer the future for us?
I think it's going basically to transform on every level, right? On the very low level, also having in mind that we are talking about OpenStack here. If you think about your data center and how you operate it, the new generations of GPUs, just purely how much power they are going to consume. I don't know, someone here in the audience, what is your default maximum power capacity per rack? Someone wants to throw a number? No number? How many watts per rack you can offer usually? Okay, now at the moment, many European data center providers, they have like 10,000 watts per rack. That's like a standard number. Yeah, this is no problem with the past generations, for example, of GPUs. You use like 3,000, 4,000 watts. The next generation will have 10,000 watts per server. So if you have one server per rack, you better control your OpenStack well, that you have enough workload on it. Otherwise, you will have one full rack in idle, no consumption. So this is the lower infrastructure layer. On the top layer, as a user maybe, we will have things like Copilot that help us every day. But maybe I'm not creative enough to think about what is in 10 years.
Any other thoughts? Yeah.
The only thing I can share with you that my productivity is already increased by 10% in average because of using these tools. So I don't know what future brings. I don't think at the current stage that it can be the basis of massive layoffs or something like that. But thinking about the opposite way, so maybe putting more work on operation teams can be maybe a scenario. But those teams will be able to manage those workloads if they use LLMs in a wise way. That's the way I see it.
Yeah, I can see a positive development where it's like we'll all have some personal assistant that's a bit dumb, but that you can still use for a lot of work, and then you have to check what they're giving you back because it might not be correct, but at least they did the bulk of the work. So there's definitely like an increase in productivity for sure. On the negative side, it feels like it's going to push the boundaries in terms of security because it's going to be super difficult to control how much your data is leaking through those models. It's super difficult once data has been put out there to predict or to prevent a model from leaking that data out. So there are like some concerns around, training the next LLM with your private conversations, and then like it's super difficult to prevent the LLM from using that part of the data inside some of the answers. So I feel like it's going to bring a lot more challenges to traditional problems in security where you would just like, well, my data is right there and it's not getting out. And this training of LLMs combined with the fact that we're using online services that will reuse whatever we type as training again. And so I feel like for people on the security front, they're going to have a lot more work on that side.
But maybe these walled gardens, what Thomas has explained, could be a solution, right? That you really have a private Gen AI solution, which is only digesting your own data and not the public ones. Yeah?
If you can make sure that it's not accessible, yeah.
Yeah, sure.
I think there's one more thing that Thomas already mentioned, and this is the AI Act, which is coming. And I'm thinking of how AI will change our work. Well, from an employer's perspective, that will give us, at the beginning, a lot of administrative work as well. On the other side, from the employee's perspective, we know it will be part of our lives, and it only depends on us how smart we are to make the best of a given AI-based solution.
Yep. Thank you. Any further
so
questions?
far, any questions? Anything else? Yeah, now it gets going.
You mentioned sovereignty in an earlier talk in the morning. How do you see the role of Europe and sovereignty in the area of AI? Like all the hardware providers are American, the chip makers are Taiwanese. So what can Europe do this in this area?
So I used to think that it would be a big problem for Europe or for the rest of the world because those models are so costly and so big and so difficult to train, and there would be like a handful of companies that would be able to produce models that actually are usable. But what we've seen with more and more opening of those models and more research being made on how you can customize an existing model, train it using your own data on top of the base model, that there's a lot of innovation in the way you can customize, make smaller models really efficient for a specific task, and that's very promising, because I was very skeptical. I was very pessimistic with the role of how much we Europeans can actually have a place between those giants based mostly in the US and some in China, but the pace of the innovation that makes those smaller models better and better every day shows that it's not going to be a complete. The game is not over, and you will be able to train with less resources in the future. You will be able to reuse existing models and customize them and train them for a specific data set on top of the existing of the pre-training, which is super expensive. So it feels like it's not going to be blocked as much as I feared it would be, and so I'm slightly more optimistic right now. But yeah, on the cheap side, it's not just like Europe versus the US. It's like NVIDIA versus the world right now, and that's actually a bit more concerning. It's almost like there is a monopoly there that needs to be broken some way or have competition for sure.
Yeah, and anyhow, I think sovereignty is getting to be a global value. So if you see now the hyperscalers, they are one by one coming up with their sovereign cloud solutions for Europe. Yeah, so I think this is how this original message is really taking root in all the providers.
Yeah, and I think also sovereignty can also just be seen under regulation, right? And sovereignty in cloud, I think, is a European thing at the beginning, right? I think in Europe, this actual activity started around Gaia X, and I think this is like a fruitful discussion, and Europe is also driving this kind of innovation, right? And I also see voices where the request for global standardization, legislation, and also accountability in matters of AI are getting louder. I just also read an interview from the Blackstone CEO. He was basically visiting China and having exactly this debate also there with the Ministry of Trade. And also from China, we see that that voices that global regulation for that is something good and that should be globally understood to be most likely required. Because it's very powerful, and we have to keep track with that.
Yeah. Thank you.
Here.
Hi, I'd like to hear your thoughts on explainable AI, in particular if you've seen it used in practice. That's the question.
Question to anyone specific, or?
I didn't hear your question, sorry.
So the question was about explainable AI, whether you've seen it used in practice. My area of inquiry is, Adam twice mentioned, it's okay, when can we trust the AI to make the decisions, for example, in AIOps? Like, it's okay to find a good solution, but when can we trust it so much that we are willing to, let's say, entrust it with our users' data or our users' funds, for example? So have you seen it in practice used by someone?
From my side, unfortunately, I haven't seen it in action. I read articles about this, and that's the problem, because we are unsure. Where is the limit from which we can trust our AI enough to give it the power to do things on its own? Because it might work in the cases of 99.9%. But how about this 0.1%? And that's the problem. And I think that's why also it's important to have this AI Act, which classifies the risk factors of given AI, how much power is allowed to be given to a given AI-based solution. So I also wish to see something like this in action, especially in operations, because I've seen it being used in sandbox environments, in safe environments, where you know if the AI does something wrong, that the damage is not that big. But how about letting it go into the wild? So that's a good question.
Yeah, I think it's going to take a while before we just let the AI act completely autonomously on things, but there are already tasks for it where it's super useful, like digesting logs, and trying or finding root causes, or at least proposing root causes for anomalies, or finding patterns in logs. That's actually super useful already, and I feel like you could have a system where it digests a situation into 5 top problems that you should look into, and using it for prioritization is also super useful. But yeah, like before you can actually put it in auto mode and not have the human take action on the data that's been prepared by the AI, it's going to take a while. And we're seeing it with autonomous driving and all those things where it's the early stages where the car is driving itself is relatively easy to reach, but then it's all the corner cases, and you just can't really trust it until it's better than a human. And what we've seen is that it can drive better than a human, but in the end it will have very weird behavior on a very weird situation, where it was just like decide to run over the person. That's a problem, and you can't really like you said, the 0.01% is like, it's already too much, because this 0.01% will not be like the 0.01% that the human would do, which is like, well, maybe they didn't stop at the stop sign. It's going to be a very weird action that's linked to a very weird situation, and that could have catastrophic consequences.
Yeah, and I'm afraid also having 100% explainable, because this is part of your question, right, is per se not by default possible, because the actual scenario that we have in these large trained models and all the weighting that is behind, all the, let's call it neural connections that are actually built to make these decisions are not like predictable as such, right? You can use 2 times the same model, it will give you 2 times different answer, and you will also not find someone who can exactly predict how it works with which information, because we don't know yet. That's also like the level of scientific research that we have done, right? So we are using something that works fine, we are implementing it and testing it as far as possible to make it reliable, right? But still, that's also what Adam said with regards to the AI Act. If there is a very critical application, most likely, I don't know, critical infrastructure, you will not let an AI decide if your nuclear power plant is powered on or off. You will just not do that. And I hope this is then accordingly regulated.
Maybe someone from the audience has some experiences with explainable AI you wants to share. So I recently ran actually over a project here in Deutsche Telekom that is an AI model that tried to implement this. And wow, it was a very specific experience, because for each statement this AI made, it required some proof or some backing, which had, in the other hand, the result that there was not much answer for that, because there have been a limited number of existing documents, and with this shortage,
I would have been curious to see the question if climate change exists.
Yeah, for example, yeah. Okay, so back to you, Zoltan. Are there still questions left, or?
Yep, now that I know about it, and with that, thank you very much for coming today. Thank you for the very good and, vital discussions that we had also on the stage. Thank you very much for all the presenters and the panel discussion participants, for all the enthusiastic participants, and all the people who prepared and made possible it to happen. So thank you very much, and see you at the next event.
Thank you for hosting us, Zoltan.
Sorry?
Thank you for hosting us.
Yeah, okay.
Thank you for being such a perfect host.
Yeah. You're welcome.
Thank you very much. The host was
Not
the
my
best,
profession,
obviously.
so I'm a layman.
So.
Okay, then see you next time around, and thanks for coming.
Yep.